trying to catch up on sleep. And it's been difficult, been busy. So here we are, back here. Trying to take a picture, turn it into grayscale. Let's see, we got the height, the width, and RGB triple image with height and width on the inside. So let's see. Now you can use image IJ. To access any individual pixel image, but how to take the average of red, green, and blue elements, recall each element of. So I think I need to like read. Let's see here. This loops. No, I think I'm supposed to do something like F read. All right. Let me see. Shit. Print. I don't need this one. The file's already open, though. I don't think I need to open the file, right? No, I don't know. Include helpers, that's the other one. This is kind of difficult, I'm not gonna lie. Because I know you gotta open the file, but I don't know. Let's see. I mean, it's using this, so maybe I'll still be able to pull it from the other file. Because it's got the image right here, but include helpers, and it's pulling from the other helpers. Alright. Oh, this one ain't gonna help me. I need somethsomething like where it shows how it reads. Because I know I got an F read. Print. Take an average of red, green, and blue. I don't know. I'm trying to figure out how this part's like. I don't feel like we touched on this part enough for me to fully grasp it. That's the only problem. And oh man, I'm trying to remember how to. Let's look at how I did this one. File input. And this was the read. Open files and determine scaling factor. Check command line arguments. Okay, this part.
Real estate data entry. Damn.
You okay?
Data entry for real estate starts at $26 to $30 an hour.
Yeah.
Oh, good. cold.
Yeah, me too, actually.
Alexa, what's the thermostat set at?
This is the hard part. So I need to read, but I need to read more than this. Image. But I don't think it's that, right? So we did header size, 1, and input. Copy header from input file to output file. I don't know. This is hard. RGBT. Oh, wait. Okay. Let's see. Recall that each element of image is an RGB triple, which is the struct defined in BMP to represent a pixel. So I feel like I need to do something along the lines of like like some along these lines. But how to take the average of red, green, and blue elements, recall each element of image is an RGB triple, which is the struct defined in BMPH. This part's hard. Let's see. Read over all the pixels. Let's see, RGB. Okay, so that's all three of those. I mean, ideally that should read it, right? If I'm typing this correctly, take the average. Okay. Update pixel values, which is the usual syntax to access members of a struct implies where will give you access to the RGB triples red value. Okay. When you compute the average, keep in mind the values of a pixel's components are all integers, so maybe round any floating points. Okay, so I gotta find the average of the three numbers. Read. Each element. Well, maybe. I mean, if RGB represents all three of them, then I can just do right. I think. I don't know. I'm gonna try this. And then I gotta find the average. Take the average of red, green, and blue. Update pixel values. Okay, let's see. If it did it here, update volume of sample. Update pixel values. So see, this isn't read singles. So it's gonna be. I mean, I guess I gotta. Red, green, and blue. Not an integer, but a float, I guess. to update pixel values. Will this work like this? Oh wait, this is the... You okay?
Mm-hmm. My brain just going a million miles right now.
Sounds like you.
The gift of ADHD.
Mm.
Can't focus on shit, but everything.
All right. Oh, we hear you yelling. Jeez.
Chill out, baby Cartman. Mama!
Dude.
Oh, my chicken pot pie! The chicken pot pie, but like you just said it.
I swear. Will that work? I don't know. Numbers. It's right here, images. Oh, filter list. Okay, let's do that. Too many errors. Just F read F right, right? Crap. I don't know. God dang, this is so much more complicating than the previous things. Oh my god. Ugh. Loop over all pixels. Take an average of red, green, blue. Okay. Does it? And later do not support us. Do I need like? Let's do that. Let's add. Is that it? Int, didnt, standard to each. This is hard. This is definitely harder than the last one. I fully understand this.
That's how you get hurt. But you're gonna find out the hard way. Stop.
Stop! Like, I get what to do, but I don't understand the correct way of writing this stuff out. I need like way more practice rounds than that. Something like. Anything. What was I gonna do? Oh yeah, it's got a video down here.
Let's dive into filter. In filter, your task is going to be to take a bitmap image and apply some number of different filters to that image. You'll apply a filter to take an image and convert it into grayscale, making it black and white. You'll take the image and apply a filter to turn it into sepia, giving everything a reddish-brown, old-time feel to it. You'll take the image and reflect it, getting the mirror image of the original picture. And finally, you'll apply a blur filter that will take the image and soften it so the details are a little bit less clear. So these are the 4 parts of this project: grayscale, sepia, reflect, and blur. But how do you go about applying filters to images at all? Well, every image, remember, is just a sequence of individual pixels arranged into a particular grid. And how do we represent a pixel? Well, on a computer screen, every pixel has 3 values, which we might call channels: a red channel, a green channel, and a blue channel, where those values range from 0, meaning none, to 255, meaning the maximum. If we set the red value to a small value, you'll see that we have a little bit of red in the pixel. A higher red value means more red in the pixel, and 255 means we have as much red as we possibly can in this particular pixel. We set it back to 0, and the pixel goes back to black. Why is it that each channel value goes from 0 to 255? Well, 0, represented in binary, is just
Go, scoot, go, scoot, go. Stop. Go. I said go. Turn around. Stop. Go. Alright, I'm going into the other room because she's just following me to harass me.
Oh, sorry.
You're good. It's not you.
Yeah.
Boo boo gaga. Go that way. Stop, Olivia. I said stop. Come on. Go. Go. Olivia. Bye.
I don't know if I'm doing this right. God dang it. Ugh.
Zero, as you might imagine. And 255 represented in binary is 8 ones.
Yes.
Which means that for each color value, we can use 1 byte or 8 bits for each color, red, green, and blue. And since we have 3 of those, we can use 3 bytes or 24 bits per pixel. So if you've ever heard the term 24-bit color, that's what this is referring to. So we can use the red channel to control how much red is in this pixel. We can use the green channel to control how much green is in the pixel. And we can use the blue channel to control how much blue is in the pixel. But of course, we don't need to just use one of the channels at a time. We can use them in combination to create any number of different colors. If we have a lot of red and a little bit of blue, we have a color that looks a little something like this. And if we have a lot of green and a lot of blue, but just a little bit of red, then we get a turquoise color that looks a little something like this. And if we set each of the channel values of red, green, and blue to the maximum value of 255, well, that pixel is just going to be a pure white pixel. If we take enough of these pixels, set them to the right color value, and arrange them in the appropriate order, the result is that we can actually see an image that looks like something by arranging colors in the correct position. So, what files do you actually need to work with in this problem? Well, there's bmp.h, which is going to store information about bitmap images. It's going to store some of the structs that you're going to need to deal with in order to complete this assignment. We've also given you filter.c, which is the program you'll run to actually run these filters, which is going to take care of the logic of reading the file from memory, calling a function to apply a filter, and then writing the new image to disk as a brand new file. Helpers.c is the file that actually contains all of the functions that are going to implement each of the filters for this assignment: blur, reflection, sepia, grayscale. Helpers.h is the header file that's going to declare all of the functions that show up in helpers.c, telling you what the return type of the function is and what all of the types of the arguments to the functions are. Finally, we've given you a make file, which when you run make is going to take all of these files and combine them together into an executable that you can run to actually apply these filters to images of your very own. We've completed all of the files except for helpers.c, and that's where you come in. So, how are you actually going to write the code to implement these filters? Well, in bmp.h, we've defined a struct for you called RGB triple, which is going to represent a pixel that has a red, green, and blue value. You'll notice that this struct has 3 fields: a field called RGBT blue, representing the amount of blue in the triple, a field called RGBT green, representing the amount of green, and a field called RGBT red, representing the amount of red. Each field stores a byte worth of information, remembering that a byte is really just 8 bits. Your task is going to be to implement the 4 functions in helpers.c: grayscale, sepia, reflect, and blur. Each of these functions takes 3 arguments: an integer called height, an integer called width, and a 2-dimensional array of RGB triples, a 2D array of pixels, where there are height rows and width columns. So your image might look a little something like this: a 2-dimensional array, which has a particular height, which will be an argument to your function, and has a particular width, which will also be an argument. So if we have an image, which is a 2-dimensional array, image 0 is going to represent the first row of that image, image 1 represents the second row, image 2 represents the third row, so on and so forth. How, for example, would you get the last row in the image? Well, if there are height many rows in the image, and we start counting from row 0, then the last row in the image is going to be image height minus 1, for example. So that's how you get a row of the image. But how do you get it at a very particular pixel in that image? Well, image 0 is a row of the image, which itself is just an array. So if image 0 is the first row of the image, image 0, 0 is going to be the first pixel in that first row. Image 0, 1 is the second pixel in the row, image 0, 2 is the third pixel in the row, so on and so forth. And we can use this notation to access any pixel in the image. Image 2, 3, for example, is the pixel in row 2 and column 3 of this particular image. So if we have a pixel, how do we actually modify the pixel to change its color values? We'll recall that every pixel is really just a struct that has values RGBT red, RGBT green, and RGBT blue. So to access the properties of a struct, we can use dot notation, using image23.RGBTRed to set the red value of the pixel equal to something, and doing the same for the green and the blue values, for example. If we set the red, green, and blue values all to 0, then we're going to turn this pixel black, because black is the color represented by values of 0 for each of red, green, and blue. Your task in each of these functions, grayscale, sepia, reflect, and blur, is going to be to take the image as input, as this 2-dimensional array, and modify the 2-dimensional array, changing the individual pixels in order to create the effect that you would get by applying one of these filters.
That didn't help me at all. So I gotta do them individually? Like, take the average of red, green, and blue. Okay, like... I mean... feel like once I get one, I'm gonna be like, Sarah got this. Man. Come on, man. No, it don't work. I don't know, dude. I need like some more info, man. I was like, take the average of red, green, blue. Okay, well, why can't I read? I thought that was the whole point. Oh my god. Let's see. How do we have it in this one? F read. Undeclared function. Dang. One thing. Okay. Line 14 is just RGBT. Yeah, but I thought that's all three of them. Maybe I can't word it the way I'm wording it. These data types are essential.
data. In the course of running your program, a file is created with evidence that it was ever run in the first place. I mean, sure, you
Dynamic memory. Yeah, well, I'm in week 4 memory. I don't know if it's considered that, but I don't know, dude. This is way harder than the last one. Oh my god. What? Are you being nice? Okay, let's see. Maybe. Let's see. How did I do in this one? Oh, God. I didn't write bytes with anything. Caviar. this is hard. Like, I get everything they're saying, but this is not... Oh, man. Working on it. It's already been read into memory. I'm not sure what it's already been read. Yes, the image data has already been read into memory for you. Each. But don't I have to read and write? Oh, what the heck? The image data is already read into memory for you, and your task is to modify this data to apply the filters. So I don't have to do this at all? Loop over all. Oh my god, this is so confusing. You don't need to use fread or fwrite directly. The image data is already read into memory for you, and your task is to modify this data to apply the filters. Once you've made your changes, the program will handle writing the modified image data back to a file. What? Okay, hold on then. Then I don't have to... Okay, so if that's the average, then I gotta make it to where... What about this? Can I do it like this? Let's do this. Let's do this. What happened? This is really. Function start undefined reference to main. BMP out dot BMP. Okay. Let's see what that did. So alright, so that works. Okay. This is so different. Okay, so I define the average and then here just update the pixels like image what's INJ RGBT, that's what I thought it was. Red equals.
I'm not holding my breath, but
You shouldn't hold your breath.
a business representative for that company makes $75,000 to $95,000 a year.
And, yeah.
That's what he's scouting me for.
I mean, just try your best. I don't know.
Oh,
Do they
there's no
care
try-
about tattoos? I don't know.
Well, it doesn't matter because it's all online. It might be remote.
Oh, I mean, that'd be
Because
amazing.
It's for life insurance, so it's just making sure that customers are happy and satisfied. And he's primarily scouting me for training because I own a business.
Yeah.
I've had 6 years in owning a business with employees.
Yeah, seriously.
So if they want me for that, I mean, technically that pay rate seems accurate. And
Yeah.
if so, then you can take your time on your schooling and your,
That would be nice.
and then yeah.
I could just fucking enjoy learning and shit and
And
stuff.
I might just fucking do that. I'll finish my real estate just to do a little side something because I really want to buy my tattoo studio location and just get Tedo to stay home and just run it for me. Because if I'm buying it and I could get him to stay, it's a award-winning artist already.
Yeah.
I need to have him when I have him, but to make sure his bills are paid,
Yeah.
our bills are fucking paid, and we own a second property.
I did it.
Ooh, that's a building. Did you make the picture?
Huh? Not the picture. I made that picture into that. I made it black and white.
Oh.
But I thought it was way, okay, my problem was I couldn't figure it out. My problem was it was way simpler than I thought. So I thought that I had to do all the work. I didn't. That's what all these other files and programs are for. This does all the work for me. Literally all I have to do is just
Link them.
do the math. Yeah, I do the loop and then the math. But I thought it was telling me, I thought I had to have it read all the pixels, then rewrite all the pixels and put them back into the location. But it already, that's what I was, because I asked it's got the little duck thing over here and the duck helps me out. Look, watch.
DDB.
Because the duck, the CS50 duck debugger.
Oh.
Because that's their thing is, they say that, I don't know, it's a whole thing.
Ah, that's cool.
But they kind of got like a rubber ducky as their mascot. I don't know what's up with the Sesame Street references, but
I'm not gonna hold my breath on getting this job, but if I do, that would take some stress off of our fucking shoulders.
yeah. No, this was like I thought I had to like you have to do like an F read, and then you have to like find where the location of the file is, and you have to return it to the file. And I was thinking I had to do all that, but I didn't. It already has all that in there, so I like the part that I did was like stupid simple. So I was just like, man, that was way something. Because that's what I was, and I used the little quack thing because I was like, aren't I supposed to do the read and the write, and it's not letting me? And it's like, no, it's already implemented. You don't have to do it. And I was like, well, shit. So I just did that. And yeah, dude, like, well, you don't take away the color. So the actual way that this works is every pixel runs off of red, green, and blue. So every pixel has 3 lights to 1. And whenever all 3 are on at 100%, you have white light.
Oh, like video wall.
Whenever all 3 are at 0%, you have black, obviously, absence of light. But like, let's say you have a lot of red and you don't have no blue and green, then you're gonna see red, right?
Yeah.
And then, but you mix them up to make different colors.
Yeah, video wall.
But if you just want something black and white, then what do?
Ah, so you're using my music knowledge for for building stages for your, but that's all derived from your shit.
I don't
Video
know.
wall is derived from your shit. You had to do the coding. You have to input the universes for video wall and lights, which is pretty much coding. So you telling me the color combinations and stuff to create the different, pretty much light and stuff. It's
Yeah,
coding.
but what's gray? How do you make gray?
I don't know. I don't do the coding. I just put the lighting boards together, but I hear people talk about it all the time, so I understand what you're saying.
Yeah, you just so if it's black when it's all 0 and it's white when it's 100% on all 3 of them, then gray is gonna be like they all just have to be the same number. So what you do is they all have different values to give colors, so you average them out and you make them all the same value, and that's what gives it gray. So if they're all at 50%, then you have a medium gray. If they're all at 25%, then you have like a dark gray. If they're all at 75%, but the second you make one more than the others is when you start
Color
giving
shifting.
it color. Yeah.
That's cool.
Pretty wild. Because what is all the color? All the colors make white. The absence of color is black. So it's just, it's crazy.
Not in the color universe, but in the lighting universe, yes.
I have to do these other ones too, so I have to do.
I'll leave you alone.
Yeah.
But I just wanted to tell you, I got an interview. My first interview, and they
Hell
scouted
yeah.
me, so that's kind of cool. I should have really just, instead of downplaying my skills, I think that's been the problem my whole life, is I've always downplayed myself too much. And I could have gotten so much further in life if I
should have used the chat GPT a long time ago.
I'm putting in a resume to do voice acting, just so you know.
I think I can.
Man, I was not expecting this to be this freaking simple, I gotta be honest. That's kind of tripping me out. I thought it was gonna be a lot more complicated than that. I thought I had to do like the whole function. Like I didn't think I just had to do a little bit of math. Okay, this is gonna be interesting though. Most image editing programs. I guess I gotta do the loop again, right? Yep. So let's go ahead and bring this loop back over.
It's $40 an hour.
That'd be crazy.
Their average pull rate is 84,000. And everything on that listing makes sense because I can do all of that shit and more.
Yeah.
Because I was like reading up on it, and I'm overqualified for that job.
Well, yeah, it's just hard to find people that. What?
Let him do his thing, babe. What do you want?
You get my attention all day. All the time. She's like, it's never enough.
Can I have you?
The attention's never enough.
Mommy's got a job interview tomorrow. I get to
swear.
put on makeup.
Hey, what's up? I was getting a little stressed out about this earlier, but I didn't realize they do all the work for you. So all I gotta do is like this basic math part. So now I'm like, this is like way easier than I thought it was when I first looked at it. I thought I had to do like all the work, but they already do it like in these other files linked to it. So I'm just like, I wasn't expecting that, but I was like, man, I thought that was supposed to be practicing the reading and writing and defining the address and everything, but I guess, I don't know, which I kind of want to play with that more, but, well, that's what, oh, wait, is this the, ooh, this is interesting. What? Juice? Dude, why don't you ask mommy? Oh my god. Dude, you drank too much juice. You need to drink more water.
I want milk.
Milk? Oh, you want milk? Okay, I'll give you milk. Oh wait, did I give you your bottle? I didn't give her a bottle. What did I do? Oh, I did give it to her. Never mind. That was confusing. No, I have to study. Oh man, what is the name of your? No. Are you talking to me? Oh, mommy's gonna take the TV.
Huh?
Mommy said she's gonna take the TV.
No.
Well, then go watch it. Go watch the TV. Olivia. Cause.
What? He's got to do his schoolwork. Come hang out with me. Come on. Come on, come hang out with me. Please. I'll play with you. Want to play? I already set up my interview stuff. I don't really need to do anything necessarily.
Yeah, I don't know. She's. She really likes the attention. Like, she doesn't like giving me time to do this. My baby. Okay. Most image editing programs. I don't know if you're still there. Her name's Olivia, though. Most image editing programs support a sepia filter, which gives images an old-timey feel by making the whole image look a bit reddish brown. An image can be converted to sepia by taking each pixel and computing new red, green, and blue values based on the original values of the three. There are a number of algorithms for converting an image to sepia. Before this problem, we'll ask you to use the following algorithm. For each pixel, the sepia color values should be calculated based on the original color values below. Well, that's pretty easy. Of course, the result of each of the following formulas may not be an integer, but each value could be rounded to the nearest integer. It's also possible that the result of the formula is a number greater than 255, the maximum value for an 8-bit color value. In that case, the red, green, and blue values should be capped at 255. As a result, we can guarantee that the resulting red, green, and blue values will be whole numbers between 0 and 255 inclusive. Alright, so compute sepia values, update pixels with sepia values. Okay. So basically, wait, can I, yeah. Oh, crap. There you go. Here we go. Do 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 do. Alright, now I need to make, if it's over 255, then it's 255. It can't be no more than 255. So what? Need to implement like an if function or something. If, is there a way I could put them like all in one? How do I make it to where they can't be more than 255 the easiest way? If I can like, Is there a way I can put multiple values in at the same time? Damn it. Wow. There. What if I do this? Why is that not doing the right thing? Am I not doing my wow correctly? Oh, I think I need to put in parentheses. Like that's what it was. Oh, man, I gotta poop. Oh my god. Dang it. This is terrible. Oh my god. Crap. I gotta go. Oh no. What is the progress right now? So I'm making filters for pictures. I already did the grayscale one, but I'm basically like, I thought I had to do more, but all I gotta do is calculate the colors. Like, here's the video.
Let's dive into filter. In filter, your task is going to be to take a bitmap image and apply some number of different filters to that image. You'll apply a filter to take an image and convert it into grayscale, making it black and white. You'll take the image and apply a filter to turn it into sepia, giving everything a reddish-brown, old-time feel to it. You'll take the image and reflect it, getting the mirror image of the original picture. And finally, you'll apply a blur filter that will take the image and soften it so the details are a little bit less clear. So these are the 4 parts of this project: grayscale, sepia, reflect, and blur. But how do you go about applying filters to images at all? Well, every image, remember, is just a sequence of individual pixels arranged into a particular grid. And how do we represent a pixel? Well, on a computer screen, every pixel has 3 values, which we might call channels: a red channel, a green channel, and a blue channel, where those values range from 0, meaning none, to 255, meaning the maximum. If we set the red value to a small value, you'll see that we have a little bit of red in the pixel. A higher red value means more red in the pixel. And 255 means we have as much red as we possibly can in this particular pixel. We set it back to 0, and the pixel goes back to black. Why is it that each channel value goes from 0 to 255? Well, 0, represented in binary, is just 0, as you might imagine. And 255, represented in binary, is 8 ones, which means that for each color value, we can use 1 byte, or 8 bits, for each color: red, green, and blue. And since we have 3 of those, we can use 3 bytes, or 24 bits, per pixel. So if you've ever heard the term 24-bit color, that's what this is referring to. So we can use the red channel to control how much red is in this pixel. We can use the green channel to control how much green is in the pixel. And we can use the blue channel to control how much blue is in the pixel. But of course, we don't need to just use one of the channels at a time. We can use them in combination to create any number of different colors. If we have a lot of red and a little bit of blue, we have a color that looks a little something like this. And if we have a lot of green and a lot of blue, but just a little bit of red, then we get a turquoise color that looks a little something like this. And if we set each of the channel values of red, green, and blue to the maximum value of 255, well, that pixel is just going to be a pure white pixel. If we take enough of these pixels, set them to the right color value, and arrange them in the appropriate order, the result is that we can actually see an image that looks like something by arranging colors in the correct position. So, what files do you actually need to work with in this problem? Well, there's bmp.h, which is going to store information about bitmap images. It's going to store some of the structs that you're going to need to deal with in order to complete this assignment. We've also given you filter.c, which is the program you'll run to actually run these filters, which is going to take care of the logic of reading the file from memory, calling a function to apply a filter, and then writing the new image to disk as a brand new file. Helpers.c is the file that actually contains all of the functions that are going to implement each of the filters for this assignment: blur, reflection, sepia, grayscale. Helpers.h is the header file that's going to declare all of the functions that show up in helpers.c, telling you what the return type of the function is and what all of the types of the arguments to the functions are. Finally, we've given you a make file, which when you run make is going to take all of these files and combine them together into an executable that you can run to actually apply these filters to images of your very own. We've completed all of the files except for helpers.c, and that's where you come in. So, how are you actually going to write the code to implement these filters? Well, in bmp.h, we've defined a struct for you called RGB triple, which is going to represent a pixel that has a red, green, and blue value. You'll notice that this struct has three fields: a field called RGBT blue, representing the amount of blue in the triple, a field called RGBT green, representing the amount of green, and a field called RGBT red, representing the amount of red. Each field stores a byte worth of information, remembering that a byte is really just 8 bits. Your task is going to be to implement the 4 functions in helpers.c: grayscale, sepia, reflect, and blur. Each of these functions takes 3 arguments: an integer called height, an integer called width, and a 2-dimensional array of RGB triples, a 2D array of pixels, where there are height rows and width columns. So your image might look a little something like this: a 2-dimensional array, which has a particular height, which will be an argument to your function, and has a particular width, which will also be an argument. So if we have an image, which is a 2-dimensional array, image 0 is going to represent the first row of that image, image 1 represents the second row, image 2 represents the third row, so on and so forth. How, for example, would you get the last row in the image? Well, if there are height many rows in the image, and we start counting from row 0, then the last row in the image is going to be image height minus 1, for example. So that's how you get a row of the image. But how do you get it a very particular pixel in that image? Well, image 0 is a row of the image, which itself is just an array. So if image 0 is the first row of the image 0, 0 is going to be the first pixel in that first row. Image 0, 1 is the second pixel in the row, image 0, 2 is the third pixel in the row, so on and so forth. And we can use this notation to access any pixel in the image. Image 2, 3, for example, is the pixel in row 2 and column 3 of this particular image. So if we have a pixel, how do we actually modify the pixel to change its color values? We'll recall that every pixel is really just a struct that has values RGBT red, RGBT green, and RGBT blue. So to access the properties of a struct, we can use dot notation, using image23.rgbtred to set the red value of the pixel equal to something, and doing the same for the green and the blue values, for example. If we set the red, green, and blue values all to 0, then we're going to turn this pixel black, because black is the color represented by values of 0 for each of red, green, and blue. Your task in each of these functions, grayscale, sepia, reflect, and blur, is going to be to take the image as input, as this 2-dimensional array, and modify the 2-dimensional array, changing the individual pixels in order to create the effect that you would get by applying one of these filters. The first filter you're going to implement is grayscale. The grayscale filter should take a color photo and convert it into grayscale, turning it into black and white. But how exactly are you going to do that? Well, let's take a look at a pixel, which, as you'll recall, has a red value, a green value, and a blue value. If all of those values are 0, the pixel shows up as black, and remember that if all of the values are the maximum of 255, then the pixel shows up as white. The interesting thing to note, though, is as long as the red, green, and blue values are the same, what you'll get is a different shade of gray. If the red, green, and blue values are the same small value, you'll get a darker shade of gray, something closer to the black end of the spectrum. And if the red, green, and blue values are all the same but are a higher value, then you'll get a lighter shade of gray, something closer to the white end of the spectrum. So your task in grayscale is really just for each pixel to make sure that the red, green, and blue values are all the same. But what value are you going to set them to? Well, you might imagine that for a lighter color, you probably want a lighter shade of gray to represent it, and for a darker color, you probably want a darker shade of gray to represent that. So if we have a color that looks a little something like this, you probably want a lighter shade of gray to represent it by setting the red, green, and blue values all to a relatively high value. But if we have a color that's a little bit darker, then you probably want a darker shade of gray where the red, green, and blue values are all a little bit lower. And one thing that we can do is just take the red, green, and blue values and calculate the average pixel value for any of these individual channels and use that as the new value for red, green, and blue. What does this look like in practice? Well, let's take this shade of green, for example, where the red value is equal to 50, the green value is equal to 190, and the blue value is equal to 90. If we take these three channel values and take the average of the three, the average is 110. So for our new pixel that we're going to convert to grayscale, we're going to take the red value, set it equal to 110, take the green value, set it equal to 110, and take the blue value and set it equal to 110 as well. The result is a shade of gray that approximately matches the brightness or darkness of the original pixel. Of course, it's possible that depending on the original color values, the average value you get might not be a whole number. In this case, the average is 109.67. Remember that each of red, green, and blue need to be integer values in the range from 0 to 255. So if the average value is not an integer, you'll want to make sure to round it to the nearest integer in order to determine what the new value actually should be. So that's how to take one pixel and convert it to grayscale. But how are you going to do it
Yeah. Okay.
for the entire image? Well, you could imagine looping
Oh,
through the
man,
image,
I
one row
got
at a
water.
time.
I need to drink
starting
more
with
water
the first
anyways.
row, then going to the next row, so on and so forth, and converting each row to grayscale, where for each row, you'd iterate one more time using...
Alright, where's this sepia one? Oh, I got these. Okay, so... I think I got this figured out. Okay. Can I do something like this? I haven't tested this out yet. But God, this would be like so much easier if I could just write it out like this. If any of these values independently are greater, then they should be reduced. But the problem here is, I don't know if I'm gonna be able to do it exactly the way I want to. Yeah? You wanna go inside here? But I'm trying to do my school stuff. Because I want to learn this stuff. Oh. What? Why? You just want to hang out with me all the time, but then you distract me. Oh, wait, no, that's not going to work. Because even if that did work, technically, then it'd take away one from every single one of those every time. Ah, man. I mean, I could write like 3 ifs, but I really hate to do that. Let's just do it. Okay, you know what? Screw it. Because I don't need to make an extra loop anyways. What? Oh my goodness. You're crazy. Why? What is happening? Oh my god. What? What? She's crazy. Do you need your baby movie? The baby show? Well, tell mommy she'll put it on for you. What? Ban Ban? I don't remember how to do that. I think it was, I thought that's how you did. Do I have to put it in parentheses? I don't think so. Oh, you don't do that on ifs. I thought it was like that. What? I have to do something. Yeah, it was in parentheses. Why is it not taking it? What? What? Oh, crap. Okay. I mean, that's... I mean, I only need ifs. Yeah. Why? What? What? Oh no. She's also yeah. The mommy's trying to get her chill, but she wants to be with me 24/7. Oh. I don't know why this ain't working though. I'm missing some sort of syntax. Maybe because I can't do this many ifs.
Hey, stop fake crying. That's not cute. You gotta get away from that door. Go do that over here. You want it? You want some? Hey, you're not using the baby show. You need a diaper? Hey!
Sepia red. Why is... Well... Ideally, this should work. But what is going on? And this, like, this should be blue. I don't know what's going on with the syntax. Let's just... Gosh, this is being difficult right now. Why? Let's see here. It's this one. Oh, wait. Oh, I see what it is now. There we go. Oh, that's all it was. Okay. Alright. Now let's try it out. Filter. God dang it. What was it? Filter. Wait, is it G? I don't think it's G because you take the image. Okay, so image input, image output, but the G is the grayscale. So what would be the input for sepia? Probably S. I don't feel like looking it up, so I'm gonna try this. Let's do S. Images. BMP out dot BMP. Dang it! Ah, crap. Okay. Images. Look at that, look at that, look at that. How do you zoom out? Oh my god, I don't want to zoom out. I can zoom in, I can't zoom out. What the heck? Oh, there we go. Control. That is cool. Okay. So I got that one. Now we gotta do reflect. Dude, this is way easier than it looked like earlier. This is insane. Okay. Whew. I was getting scared. Getting scared for no reason. Okay. reflect. Which topic? I'm on week 4 in memory right now. We learned about because you use the get string, but we learned about pointers, because like a string is a pointer, and technically it points to the first character, because you know it doesn't technically use strings, it uses individual characters, and when you use get string, it points to the first character, you know, that gives you the list of characters. But we learned about pointers, and was the how to implement like files, and how to find an address for like a variable, for example. So how to locate a specific address, because that was part of the whole pointer thing. I mean, that's what pointers do. So, and it was like if you wanted to, because that's how a lot of this stuff works. But I'm not having to do that part here, which I'm kind of surprised about, because it's all implemented in like the other files that come with this. Like, let's see. Yeah, like here, see, like you know, you use the star symbol, because it's like you're putting in this, you're putting the value into a specific address. And then when you have the, what's the the and sign, yeah. I'm professional. I'm not a professional, but yeah, this sign, I forgot what he called it, the astronom, I don't know, whatever it was called. That one is the one where you, this is the one where you write an address, and this is the one where you read an address. So yeah. Oh, well, you also have the read right here that actually says that. But yeah, this is like at that address, and this is like defining this address. This is putting it, yeah, and this is what the W here is for write. Yeah. But I was surprised that I thought this is the part I was going to be doing, and I was like, man, we didn't talk about it that much. Like, I kind of get it. And then you always put if output equals null, then you know you return a number, so that if you have any issues because you're forcing it to do something, basically, and you don't want to mess it up, that this is one of those situations where if you don't put something like this correctly, then that's what messes your computer up, makes it. Or there was another one too where it was like, oh really? Appreciate it. I'm super into it, so I mean, I'm just like, I enjoy it. It's a personal thing, and when you enjoy something, you get into it more. And then the other thing was if you create a file, then you have to also release it. What was the like he used a specific, which I don't know if, yeah, it's right here. You free the memory of it. This one. So this is one of those things that he was saying too, where like if you create something, if you force something into an address in the computer, then you have to free it at the ends, because if you don't, then it becomes one of those things where like over time your computer becomes slower and slower. And like this is one of those reasons, but because people don't put this. Yeah. You're in. Well, yeah, appreciate it, man. I mean, they call it a week, but it's like, I mean, I guess it kind of just depends on how much time you have, so, and like how into it you are, if you're doing it because you want to do it, because you actually enjoy it, or if you're doing it just because, I don't know, you want a job, or you hear it, like, you know what I mean? I got a personal interest in it. I've always wanted to get into this stuff, so I think that's something that helps me out. Oh, where'd my pointer thing go? I can't see anything. Oh, do I still got something? Oh, why does it look like that? I don't know what I did. Oh, wait, crap. Oh, where's this file? can't type anything anymore. No, I can, but it looks weird. I don't see my little thing anymore. I don't like that. You okay?
Fucking phenomenal, man.
Oh.
My life just opened up to anywhere from a $80,000 to six-figure job.
Yeah, that's awesome.
I mean, it makes sense, especially when I'm reading up more and more about it.
Oh,
Send
yeah.
out my resume to a couple extra people.
Honestly.
Because I think that's what's fucked me over my whole life.
Well,
and I
'cause
don't
you
know,
can-
I still do it. I downplay myself too much.
Yeah.
Like, on everything I do.
Well, that's like HR stuff too. Like, I mean, that's
Yeah.
what HR does, is a lot of stuff like that. Okay, reflect. Okay, we're gonna do the same thing with the loop. So we go over every pixel.
For a minute there, I was thinking I was gonna have to sell my feet pics to keep the tattoo studio alive, man.
I'm streaming.
Oh.
God, why do you guys say weird stuff? This is where I got
That's
no
funny.
show.
I'm a funny guy. I'm that guy.
Hey, was it Peggy Hill did it off of King of the Hill?
Huh?
Peggy Hill off of King of the Hill.
Oh, yeah.
Remember? But she didn't know it was like a dirty thing. That was what was funny about it.
My first job interview since... It's been 15 years since I've done a job interview.
Yeah.
I have to put my call center voice on. Hi, how are you doing today? Yes, I am the candidate you want to hire.
You sound like a robot.
I know. Isn't it quaint?
There's Chat GPT. I swear. Oh wait, what? I didn't mean to type that. Swap pixels. This one's gonna be interesting because instead of just adjusting it or changing the values, I gotta flip the values by row, but not column. So in order to do that, I have to only change. I need the height to stay the same and the width to be flopped reverse backwards. So yeah, I'm only swapping the width, but I need the height to stay the same. So how do I see? It's gonna be interesting. Some filters might also move pixels around. Reflecting an image, for example, is a filter where the resulting image is what you would get by placing the original image in front of a mirror. Any pixels on the left side of the image should end up on the right, vice versa. Note that all of the original pixels will still be present in the reflected image. It's just that those pixels may have been rearranged to be a different place in the image. Okay, in the reflect function. Oh, we did something like this earlier. Hey, what do we do? We did, it wasn't volume, it was the swap thing. I think it was this one. No. Oh, yeah, this is what it was. This was the one where we swapped within the address without, but we had to use a temporary placement for it. But how would, I mean, this is a lot simpler. You're just replacing one spot with the other. But if, let me think. If you're doing it with this one, how would I create a temporary placement? Yeah, that's gonna be different. That's gonna be different. What?
What? It goes,
My phone number is off. My phone is off for like a split second, and I got random numbers go. You want to go eat?
I go eat.
You want to go eat? Okay, let's go eat. Come on, me and you.
I swear.
Where are we going?
Mine?
To yours?
I go
Okay.
eat.
Yes. You gonna make me some food?
How would you flip that around? Trying to think. Let's see. Any pixel, yeah, I mean, I get that. So, like, if it's a pixel 100, then you want to, if it's the very back pixel, you want to send it to the very front. If it's in the middle, though, how do you do that in a repeated function to where, let's see. I'll go ahead and let's copy this over. So I got something to work with. And we'll get rid of this. All right. Just swap pixels. How do you? I need to take it so it's at 1, and then swap it with the one on the end. How do you? Note that all of the original pixels values still be present in the reflected image. It's just that those pixels may have been rearranged to be in a different place in the image. Need to swap the values of pixels on opposite sides of the row. So pseudocode, okay. Recall from lecture how we implemented swapping two values with a temporary variable. Yeah, that's what I was thinking. Temporary variable. No need to use a separate function for swapping unless you would like to. Okay. And now's a good time to think about your nested for loops. The outer for loop iterates over every row, while the inner for loop iterates over every pixel in that row. Okay, so I probably gotta do some inside this one too. Well, this is going based off of height. I guess time to think about your nested for loops. The outer for loop iterates over every row, while the inner loop iterates
Motion
over
detected
every
at front
pixel.
door.
To successfully reflect a row, though, you need to iterate over every pixel in it. Okay. But what's a way I mean, even if I send these to a temporary, okay, let's just say temp R. Green. Temp blue. Put these over here as integers. do I make it to where it goes to the opposite? And it's just the width, so it's just this one, the J. How would I make it to where J swaps? I don't know the size of it, so I kind of need to just come up with a math way to do it. Because I can't just add it or subtract it. I need the center to stay in the center too. So, what if I do something like... What formula could I come up with for that? Motion detected at front door. Check it now. Oh, I got a camera. It's just the wife and the baby. They went outside for a second. I got a camera like right here at all times. So. Kind of. Like, I understand it wants me to use temporary, so I don't replace it. But also, how am I going to swap it to... Because it's going to save this. And then once it exits this... Because it's going to do this every time, so this number is going to get replaced. So whatever I do, I need to do it within the loop. Or outside of the loop? Wait, okay, this is the height, so this will go... trying to think. If you take something, you put it down, how do you swap it? If you pick up the first one, then you send it to the back. But then if you pick up the second one, you need to send it in front of that one. So the first one, you can send it to the back. But the next one, you gotta send in front of that. Oh, man. Yeah, that's where you're going to start. You're going to start at the 0, 0 pixel. And you have to send it to the back, which is easy. You just take away 1, and it'll send it to the back. But then when you grab the second one needs to go in front of the back one. So you can't put take away 1 at that point. You'd have to put like take away, what, 2? I think. Or what would be like a sort function? No. Couldn't do a sort for that. I just gotta figure out the right way to. Okay, right here I'll grab it. And then maybe make another 4 loop again? Maybe that's what I should do. Let's do, let me think. 4, have another loop on the inside to put it in. Maybe that'll work. And, alright. Trying to think, J's the width. Okay, maybe. And make it to where this equals. I mean, I could put it equals 0, but that's not really what I want. I need it to be equal to the total number of pixels in the picture is what I really need. Well, width should have the total width, right? Integer and width. So k equals width. Maybe that'll work. Equals width. Then k. While k, it's going to be the total number. So while it's greater than 0, then k take away 1. Right, yeah. And then what I could do down here, if this all works out correctly, what I'm gonna do is swap these around. Okay. Trying to think if this is really gonna work though, because if it's you go on this loop and then you go on this loop, but you have to run all the way through that loop, right? And then within this loop, then you go to this loop. I mean, it kind of works, but like I need it to where it does one at a time. But these loops, this is gonna, well, no, it goes in here one, then it goes in here one, and then it's gonna finish this one out. But will it take turns if these are at the same length? Or will it's just gonna cycle through this loop first? You know, I'm just gonna have to try it. We'll do trial and error. Try it out, see what it does. Alright. Okay, and then we'll swap these around. So this, instead of K here, it's gonna be K, 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 and then I need to swap these over. Just gotta put this over here. Oh wait, I don't like that. Oh, I don't need to put integer here anymore. I have to redefine these? Or they only exist within that other loop? I don't know if this is gonna work. Cause that's the only thing is this is gonna run down, put all these in temporary. But it's not gonna take turns with these. Hey, what's up? Trying to figure out the best way to do this. I don't think this is gonna work though. No. It's like, yeah, because these are outside of that loop, so they're not gonna be this anymore. They only exist within this loop. God dang it. But then if I put it inside the loop with this one, then it's gonna run this before it's able to run, take turns with it. Wait, unless I don't do the for loop. What if I don't need to do that? Oh, you know what? Because this is going to be running as many times as that is anyway. So what if I just make an additional integer k? And it's equal to the width. And then every loop, the k takes one away. Then I could put this at the... Well, I mean, I could technically leave it here. And get rid of all this. Right. I'm gonna go like that. Like... I mean, technically, wouldn't that work? Let me try this. How do you type it again? Filter, reflect, images, yard, cramp. BMP count dot BMP. Okay. Where's the other one? I didn't do nothing. Nothing. Absolutely nothing. Okay. Well, kind of thought that would work. Did I didn't make filter there? Yeah, R's for reflect. Okay, so it grabs the value of 0. K equals width. Click. Thought that should have worked. This runs down and it'll be, yeah, the width at 0. It'll be J0. Error. Let's see if it grabs it here. Hold on, where's that swap? Make it terraform. Yeah, do A, and then A equals B, and B equals temporary. Wait. Okay, so I took the original image and I put it in a temporary. And then I replaced the last image with that. But I didn't replace the original image with the last one. So I need to take these. Oh, no, wait. I put these into temporary. So instead of doing this, no, I can't do that. Okay, I need to do like these. Hold on. Okay, I know what to do. I got this. Not necessarily this, but okay. So those become a temporary file. And then I put the temporary file in here. I can't do that yet. I need to say that these are equal to these. Let's try. Yeah, I could put these are equal to these and then do that. Okay, let's do that. Damn it. Okay. that. Oh, wait. Oh, the equal sign. Okay. So now no one's overwriting it, right? Okay, so those went into a temporary file. No, wait. I can't do it like that. No, I did this backwards. I need to do this on this. God dang it. Okay, hold on. Let me swap these. These need to go on this side. See, There. Now nothing's getting replaced. Yeah, those become those. That moves to that, and that moves to that, then that moves to that. Okay. I think this is right now. Yeah. Okay, let's try. Oh, you know what? I always forget about this. Core domes. I don't know what that means. Crap. That don't sound good. Segmentation fault. I thought that should have worked. I mean, I don't think I need to do that, but I could. Hold on. I don't think I need to do this. Define to the address of. I thought I already did that for me, but I don't know. I don't think I need to do that though. I think it's already got that in there. Thought it did. I shouldn't have to do that. It should already be implemented. Okay, let me see. Oh, K does not equal 0. Why'd I put that? What? That's what I meant to put. There. Now. Watch. Let's see. Did it swap it? No. It didn't swap it. It printed out a picture. It's not. K equals width. K takeaway. Taking the original image. That should work. What? Alright. What? not doing anything. Hmm. What the? I don't know why that's not doing anything. That looks perfect. That's all I gotta do is swap it. Red, blue, green puts it into temporary integers, right? And then the I and the J, the original ones, now become the last ones. Okay. And then the last ones become the temporary ones that were the first ones. So what the? That should work. What? Come on now. I mean, that's a swap right there. Like what? Ah. And then K starts at the total width. And then every loop in the 4, K's takeaway. I mean, I don't know. I mean, I could do this. I mean, I don't know how else to. Move this to the bottom. I mean, would that make a difference? Nope, I didn't do anything. K equals width. I mean, why isn't it working? Put R. if this is working correctly. I'm kind of just. Let's see. Everything else was working. Let's see. If I do S. That worked. If I do. That works. Okay. Oh my god. I swear, dude, that formula is. How is this not working? That's the width. Why aren't you working? I don't know. I don't know why it's working. I don't get it. I don't know. I feel like that should be working. I don't understand. I mean, I could put the stars, but I don't. It's not gonna take that, dude. Like. think that's what it wants me to do, but I'm like at a loss. I don't understand, man. This don't make no sense. That should work, dude. If it's not working, I don't know what else to do. Dang it. This is not working. Huh. Well, fuck it. I'm gonna do this one because that's kind of irritating. The I, I mean, it's all there. I, the J, width. Come on, man. I, the highest edge. So pissed off. God damn it. Oh, I feel like that should work. Okay, whatever. I'm just gonna move on because it's pissing me off. There are a number of ways to create the effect of blurring or softening the image. For this problem, we'll use a box blur. And for it, each color value, giving it a new value by averaging the color values of neighboring pixels. Consider the following grid of pixels where we've numbered each pixel. The new values of each pixel would be the average values of the pixels of all of the pixels that are within one row and column of the original pixel, forming a 3x3 box. For example, each of the color values for pixel 6 would be obtained by averaging the original color values of pixels of pixel 6. Oh, all surrounding, so the entire circle. Okay. Note that pixel 6 itself is included in the average. Likewise, the color values for pixel 8 or pixel 11 would be obtained by averaging. Okay. When implementing the blur function, you might find that blurring one pixel ends up affecting the blur of another pixel. It might be best to create a copy of image by declaring a new two-dimensional array with a code like RGB triple copy. Then copy image into copy, pixel by pixel, with nested for loops like so. This is kind of racking my brain that this is like not working the way I want it to. Like, I don't know how else I would write this. Dang it. Well, it did something. Why is it not reflecting it? It's doing something. So what? I probably just grabbed this, the first row of imaging, and then what, stretched it out all the way across or something. It's one flat color. Oh man. See, I feel like this should have worked right here. Like, that's perfect. Just doesn't do anything. This reflect thing is gonna drive me crazy. Okay, create a copy of the image. When implementing the blur function, you might find that blurring one pixel ends up affecting another pixel. It might be best to create a copy of the image by declaring a new two-dimensional array with a code like copy image into copy. Damn. Copy image into copy pixel by pixel. I mean, is that what I need to do here? Alright. There's the swap function. second. No, yeah, I need that. This is the same height. What am I doing wrong? I'm just gonna look at all that. $83. $93. God dang it. I'm even trying to mess with this right now. God dang. I don't know why it's not swapping. It's pissing me off. Learn CVP. Yeah, I played with C++ a little bit, but it's fucking bullshit. God damn it, fucking motherfucker. Okay, son of a biscuit. Okay. Doesn't make no sense. Integer width. Yeah. You already drank a gallon of juice. Oh my god.
Come here, Olivia. Let Daddy finish his work. Yeah, Daddy needs to finish his work. Baby. You want to get some food?
This doesn't make any sense. Why isn't it working? I'm literally doing it perfect. I've written this out so many different ways and it's not doing anything and I can't figure it out. All you're doing is swapping the first one with the last one. Why doesn't that work? Why doesn't it? Like... pissing me off. Rage baiting. No. Fuck, I don't know. This is pissing me off. This thing's not working, and I don't know why. I done rewrote it like a million different ways, and it's just, I don't know, screw it. Move on past it, because it's pissing me off. Like, I can't get the motherfucker to, like, piece of shit. Good God. Fuck. Don't make no sense. Like, this should work. Why? Fuck you. Oh my God. Piss me off. Okay.
I like this. I like this.
Oh, it's right here, but, you gotta go through EDX to get it, but, I mean, that's it. This shit should work right here. This is really pissing me off. Like, that doesn't make any sense why that's not working. Stupid. Fucking stupid. Fucking. It doesn't make any sense why that's not working. None. Zippo. Okay, fucking pissing me off. So irritated. Okay. When implementing the blur function, might find that blurring one pixel instead of another pixel. Maybe best to create a copy of the image by declaring a new two-dimensional. I can't figure out why that's driving me nuts. Why the reflect isn't reflecting. It's pissing me off. Okay. When implementing the blur function, you might find that blurring one pixel ends up affecting the blur of another. Okay, copying the image. Now you can read pixels, colors from copy, but right, change pixels, colors in image. We use that to copy it, and then I can take the copy and use it to so I created a copy. But then I need to make another for loop. how do I do it to her? I gotta add all the remaining. Okay, I gotta find the average. Everything around the number 1 pixel. And then divide it by that number. So, let me think. Probably do like this again, right? Except get rid of this. Oh, no, wait. And then what I'll do is the image. I gotta create a formula. How am I gonna do this? This is okay. So if you're starting here, you're gonna want a negative 1. Then you're gonna want a positive, and then you're gonna want a negative. Okay. Let's just create a function for it. Screw it. All right. So let's call it the blur. No. Screwed. One, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah. Do this +1. Take away 1. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Let's see. And then it's I take away 1 plus wait I plus 1 take away 1. But the other side. Oh yeah, because take away is up here and plus down here. Okay. And then parentheses. All of that. And then divided by 9. Image. around it like that? I think so. Oh. Assigning to RGB triple. Incompatible type. Come on, man. Why are you being a little punk? Assigning to int from incompatible type. I don't know why this is such a pain to figure out. You can't just copy the full thing over? This kind of sucks. Ugh. I don't understand this bullshit. Might have to do this individually or something. I mean, this don't. God dang, dude. Alright. Fuck. Oh. Alrighty. Fuck you. I don't know.
Yet another loop. Starting with the first pixel in the row program, you can run /filter, passing in -g as a command line argument, indicating that you'd like to apply the grayscale filter, passing in an input file as infile.bmp, or whatever the file name happens to be, and then specifying the name of the new file you'd like to produce as output, outfile.bmp, for example. If you do that, and pass it an input file in color, if you've implemented the grayscale function successfully, after you run the program, you open up the out file, you should see the same photo, but converted to grayscale. My name is Brian, and this was Grayscale.
Well, please know that there are 5 videos in this playlist.
Next up is sepia. In the sepia function, your task is going.
Okay.
The next filter you'll implement is a reflection filter, where in this filter, you'll take an image and produce the mirror image of that original picture.
Let's see.
How are you going to do that? Well, recall that each image is really just a 2-dimensional array, where we have rows, and every row has individual pixels inside of that row. We could number the rows in this image, so we have row 0, 1, 2, 3, 4, and 5, for example. When we take the mirror image of this picture, what really happens is that the rows stay in the same order, but the pixels in the row switch places. So that row 0 is still at the top, but it's been reflected. Row 1 is still the second row, but it's been reflected, so on and so forth. So what we really need to do in order to take the reflection of an image is just to take each row and apply the same filter to each row, taking the individual pixels in that row, which might all be different, and reflecting them, so that the pixel that was originally on the far left of the row is now on the far right. The pixel that was originally second from the left in the row is now second from the right, so on and so forth. If there are an odd number of pixels, as there are in this particular row, you'll notice that the middle pixel, the pixel at index 5, doesn't actually change position. But if there were an even number of pixels, then every pixel would switch positions with the pixel on the mirror image side of it on the opposite end of the same row. So what is the algorithm you're actually going to implement here? Well, for every row, you're going to want to swap the pixels on horizontally opposite sides, where the far left pixel becomes the far right, and vice versa. And once you can do this for one row, you can repeat this using some sort of loop, applying it to every row in the image, swapping the first row, then the second row, third row, so on and so forth. After you've implemented this function, you can test it by running /filter -r for the reflect filter, then passing in an in file and specifying an out file. Once you do that, if the input file looks like this, then the output file should be the reflection of that original image. My name is Brian, and this was Reflect.
That didn't work for me.
Finally, the last filter you'll implement is called Blur. In Blur, your task is going to be to take an image and create a blurred version of the same image, where everything is a little bit softer. Let's zoom into this image a little bit to see what this actually looks like. Notice that if this is the original
I know what to
image,
do, I just don't know how to word it in this
looks like.
stupid coding
Notice
crap.
the details are a little
God
bit
damn,
softer.
fucking-
It's a bit tougher to make out. So what does that algorithm actually look like? How do we take an image and blur it, so to speak? Well, let's look at this image. a simple 6x6 image where we have red and blue. And what would it look like if we were to blur the image? Well, the blurred image might look a little something like this, where the details are a bit softer, and you can't quite make out the lines as crisply. The average amount of red across all 9 of these pixels is 142. 5 of the pixels have the maximum amount of red, and 4 of them have no red. As for green, none of these...
Okay, I mean, the only thing I can think of is RGBT and blue, green, red. Was it working up here when I was timing this shit out? I mean, it's still not gonna work, 'cause that's not even... Because it's saying incompatible type integer. Because the x is an integer. I mean, I can't fucking... I don't fucking know. Well, that don't work either. And then it's a binary expression. Dude, I don't know what the... Like, this shit's so fucking simple, but writing it out in this coding shit's fucking... It just doesn't fucking work, bro. Like, it's simple crap, but the fucking... When you try to put it in code, it doesn't fucking work. Oh my god, this is fucking stupid. I don't know how I'm supposed to fucking word this so this stupid motherfucker will do something like this. Don't make no fucking sense to me. Like, how in the fuck am I supposed to word this shit? I can't even round X. I don't know why, this fucking motherfucker. I don't even think I need to do this crap. Like, I just...
Pixels have any green at all, so the average amount of green is 0, and the average amount of blue is 113. Again, all of these rounded to the nearest integer. So what that means is that the blurred version for this new middle pixel is going to be based on the average of the original color values for all 9 of these pixels, which means it's going to now have a red value of 142, a green value of 0, and a blue value of 113. Finally, the last filter you'll implement is called blur. In blur, your task is going to be to take an image.
Oh, it's just pissing me off.
And create a blurred version of the same image, where everything is a little bit softer. Let's zoom into this image a little bit to see what this actually looks like. Notice that if this is the original image, this is what the blurred image looks like. Notice that the details are a little bit softer, and it's a bit tougher to make out. So what does that algorithm actually look like? How do we take an image and blur it, so to speak? Well, let's look at this image, a simple 6x6 image where we have red and blue. And what would it look like if we were to blur the image? Well, the blurred image might look a little something like this, where the details are a bit softer and you can't quite make out the lines as crisply or as sharply as you could before. You can look at them side by side here. On the left is the original image, and on the right is the blurred version of the same image. You'll notice that the pixels have changed their color values slightly. The pixels that were originally just pure red now look a little more blue, and the pixels that were originally blue now look a little more red. So how do we actually do this? Well, the type of blur we're going to do is what's called a box blur. And to implement a box blur, we're going to compute the new value for a pixel by taking the average of the old color values of all of the 9 pixels that form a grid around that original pixel. In other words, all of the pixels that are within one row and one column of the original pixel. What does that mean for an image like this? Well, if we take this pixel, for example, and we want to compute its new color value in the blurred image, we're going to do that by looking at the original color values of these 9 pixels, the pixels that are within one row and one column of that pixel. Likewise, to determine the blurred version of this pixel, we're going to take the average of the original color values of these 9 pixels. Of course, not every pixel in our image has 9 pixels that form a 3x3 grid around it. Let's consider an edge case, for example, like this pixel. What happens now? Well, instead of averaging 9 pixels to get the new color value for this pixel, we're instead going to average these 6 color values, because these 6 pixels are the only ones within one row and one column of that original pixel. And likewise, if we look at this pixel down in the corner, we're going to compute its new value by taking the average of these 4 pixels, the only pixels that are within one row and one column of this particular pixel. So let's take a look at an example in a little more detail by calculating the new value for this pixel if we were to try and blur this image. In order to do so, we need to look not just at this pixel, but at all of the pixels within one row and one column of it, which will be this grid of 9 pixels. Let's take a look at them in more detail. Notice that the blue pixels have a blue value of 255 and a red and green value of 0, and the red pixels, of which there are 5 of them, have a red value of 255 and a green and blue value of 0. So what are we going to do to filter the pixel in the middle here? Well, what we're going to do is calculate the average amount of red, the average amount of green, and the average amount of blue. The average amount of red across all 9 of these pixels is 142. 5 of the pixels have the maximum amount of red, and 4 of them have no red. As for green, none of these pixels have any green at all, so the average amount of green is 0, and the average amount of blue is 113. Again, all of these rounded to the nearest integer. So what that means is that the blurred version for this new middle pixel is going to be based on the average of the original color values for all 9 of these pixels, which means it's going to now have a red value of 142, a green value of 0, and a blue value of 113. If we do that same process for each of the pixels in the original image, determining the new color values for each of red, green, and blue by taking the average of the original color values for all of the pixels that are within one row and one column of that pixel, the end result is an image that looks like this, a blurred version of that original image. And once you've done that for every pixel in the image, you can test this by running /filter, passing in -b to specify that you want to run the blur filter. Finally, the last filter you'll implement, the next filter you'll implement is a reflection filter, where in this filter, you'll take an image and was reflect. Output file looks like this, R for the reflect filter, then passing in an in file.
I don't know why the reflect one isn't working. This stuff pissing me off. And file. Oh, file. This fucking piece of shit. Couldn't even get the reflect one to work, and I don't know why. So pissed off. Well, he didn't tell me anything I didn't know, so
Finally,
this is awesome. Okay, so we're gonna use this to copy it. So I'm just gonna go fucking fuck. I don't know why that's not working. Oh, it's pissing me off. It's pissing me off. It's pissing me the fuck off. That should work. That should work. But it's not. That's pissing me off, dude. I can't fucking. This is just pissing me off. Okay. Fuck. So, I gotta figure out how I'm gonna do this. That creates a copy of that, so now I have a copy of it, and then I gotta freaking blur out everything around it. Oh, dude. This is kind of irritating. Expected an expression. Wow. Hey, the blur thing was not hard at all. Now if I could figure out what the heck I'm doing wrong with the reflect. That's the only one I got left. And it's so stupid. Okay. Reflect image horizontally. I mean, that should work. Honestly. Maybe I could like copy and do like this. Honestly, like, can I just do this? Like copy this here. Because I don't know why it's not swapping them. I can't figure this out. It don't make no sense to me. It gotta be something like, because if K is the width, and it's swapping this with the last one, I mean, that should be working. That's what it doesn't make any sense to me. Why am I having trouble with just this one? Yeah, it's not working at all. Let's see. Do I need to make an additional loop? Like, see if I switch that one's just the height. Integer I is the height. God dang it. And if I put it outside the, I need to put it on the inside of the loop. Okay, this is what I'm thinking. I'm gonna say screw this. Try it another way. Let's go ahead and just make another copy function. Screw it. Because I'm kind of running out of ideas. But I can make a copy of it. And instead of using the swap function, I guess. Because I don't know what else to fucking do. It says loop overall, but like I don't know what else I could possibly do, dude. Honestly, like, and then from there, I can just do this function within it. I might even be able to just do the swap function. Let me see. Okay, so I'm just gonna copy everything, and then what if I do like another? Come on now. Come on now. I'm gonna make this thing work. It's gonna work. It's gonna happen. Less than, greater than. Okay, is greater than 0.
It's almost time to pick up your child.
Dang, it's still not working. It's not swappable. Why am I having trouble with the reflex of all of them? Like, I don't understand, dude. You okay?
What's up? I gotta go get Cora, then Sativa, come back home. Just booked Mimi's doctor appointment because she's not doing them now.
Oh.
She's got staples in her hip. They need to be done. Taken out.
Well.
She's like, I forgot. I was like, how? It's right there. She's...
Dude, I skipped over the one that's pissing me off. And I did the last part, and I went back, and I still don't know why the fuck this one ain't working. I'm trying it like multiple different ways to try to see what I'm doing wrong, but I do not. I don't get it.
You want me to take her?
I mean, it's up to you. I'm not trying to put a bunch on you.
Put her in the Escalade, she'll fall asleep.
Yeah, maybe.
Or I'll leave her here with you.
Yeah. You could take her with you to go pick up Corin if she's...
Well, I'm gonna shoot straight from Cora to Sativa.
I was just
You want her
saying...
to drive with me, or you want to stay here? Drive, okay. She's going with me.
Of course.
Alright, love you, bye.
Love you. You want a kiss?
Yes.
Olivia, she's like, well, me too. Look at her. Love you. Love you.
I'm tired. I don't even want to do anything tonight. I'm exhausted from yesterday.
Yeah.
Back-to-back movies, it seems.
Staying up all late. Not want to go to sleep.
Keeping me up.
Jesus. Ew, no, we're having lots of issues. Correctly filter single pixel with whole number average. Filter compile, grayscale correctly filter single pixel with whole number averages. Expected. Actual 27. This is bad rounding or what? Oh, they're goddamn grayscales. Leaves alone pixels that are already gray. Grayscale correctly. Filters simple 3x3 images. Correctly filters more complex 3x3. Expected. It's literally off by 1. So it's the rounding that's incorrect. Okay. So the actual, okay, so it's rounded lower, so instead of this, I need to do like float. And then round. God dang it, I don't remember the freaking thing for it. Where's that stupid website thing? Oh, God, Jesus. Come on, man. Where's the goddamn? I don't remember which one it was in. Apparently I'm not using it correctly. Double. Why isn't it rounding off correctly? I swear to God. Let's see. Why do you suck? I don't know why you suck. It's off by one number, you son of a biscuit. Why isn't it rounding up? Let's see. Maybe not use round. Maybe something else. Ceiling, calculate to the ceiling of a number. Calculate to the floor of a number. Calculate to the best. Raise a number to a power. Round a number to the nearest integer. Calculate the square. Let's try. Let's just do that. I mean, I'll try that, I guess, right? Fucking motherfucker. Still doesn't work. It is stuck at one number off. Literally. Like one number off every single time. Okay. Motherfucker. Okay. Well. Ceiling. I don't know what ceiling did. The smallest integer that is not less than x. Okay. See, round should work, honestly. I mean, shit, even if putting it as a double, that should have worked. Oh my god. You're really gonna be off by these stupid decimals, bro. Like, oh my god, it's gonna drive me crazy. So be sure to round any floating point numbers to the nearest integer when assigning them to a pixel value. And why might you divide the sum of the integers by? So, yep. Okay, let's try this. Let's try not doing that. Let's try turning this into a float. And then we'll do average divided by 3. Let's see if this helps. We're struggling to find that perfect freaking number. Okay. Oh, bro, this is stupid. Come on now. I don't know why it's not rounding it correctly. I hate like getting stuck with this tedious crap like this. Like this is so just tedious, like it's frustrating, man. Lesson here in okay, let's see. Oh god. Oh my god. This is frustrating. I mean, like, this is so tedious over some dumb BS. Good God, man. Like, I get how everything's supposed to work, but this fucking bullshit. suck. Can't do that. Nope. Can't fucking do that. Okay. Let's try this. Trying all sorts of shit to try to figure out what am I fucking missing to make this absolutely fucking perfect. Oh my god. Such bullshit. The grayscale correctly filters single pixel without whole number averages. It's off by one fucking number. What is going on with my rounding? That's all it is the rounding. Like, the rounding is not perfect. That's the problem. That's the fucking goddamn. Do I need this one? Okay, I'm just gonna lose it. I'm gonna lose it. I know it looks like it works, but apparently I'm off by one fucking number. So I don't know what else to do. Oh, this is driving me crazy. Driving me crazy. You piece of shit. I don't understand. I don't understand why this is not rounding the way it's supposed to. I mean, I could just put a fucking 0.5 and try to force it to round up. I don't fucking know anymore. Like, what the fuck, dude? This is stupid as shit. This is fucking dumb. Be sure to round any floating points to the nearest integer. I'm trying, buddy. There it goes. Put a 0.5 in it. Apparently that helps it. That don't make no fucking sense. This is stupid. I gotta do sepia. Like what? Like why? This is... Oh my god, it's gonna drive me crazy. I need sepia to round. So let's do this. I'm gonna have to do the same thing for this one. Good god, bro. Can I just do this? Like, I don't want to type all this crap, dude. I'm already irritated with this stupid thing. Can I put this? Will it let me put this? Yes, it will. I'm gonna do this because this is the only way I can think of doing this crap. because it's already integer up there. Nope. Hold on. Oh, 101, 89, 70. Holy but Jesus. Oh. That's too high of numbers. Maybe I can take this away. Maybe I can just round it this time. Please? That'd be cool. I mean, I want to complain about that. Okay, sepia works, grayscale works. Okay. Reflect correctly filters image that is its own mirror image. What? The blur apparently doesn't work. Is not given the right numbers. Blur correctly. Okay, well. You're asking for a lot from me, buddy. Okay, well. A 3x3 image. A 3x3 image, a 4x4 image. Correctly filters pixel and edge, corner. 4x4, 3x3. Okay. Now, the reflect isn't reflecting at all. So let's see what I can do. So reflect, make a copy, and then I could try doing this. Oh, that ain't gonna work. Never mind. Oops. I mean, do that. Alright, let's see how this one looks. Probably not. Oh, wait, no, that's backwards. That definitely ain't gonna work. This needs to go on this side. This needs to go on this side. This needs to go on this side. Okay. Put this in the middle. Put this in the middle. This in the middle. Try that. Okay, okay. Come on, man. Nope, still doesn't flip it. Why isn't it flipping it? Make a copy of it, eh? That's the K thing. K equals fucking hell, bro. -1. I don't fucking know. Okay, what if I do something like... greater than the width. I, and then J plus, I. Damn it. Well, no, because I would just swap it to the... I'd just swap it over one. That couldn't work. I need like a... K... K equals J. Take away. Oh. See, I ain't even gotta put that really. I mean, this is... all this should have to do is relate something to the width, bro. Like, dang it, man. This is your K equals width. I mean, that should be it. It's like, this should work. And then this, like, I don't know why this ain't working, but this is the, man, like, and then you should just do like K take away equals fucking 1, bro. Like, that should be it. That should be it. Like, but it's not gonna work. I don't know why. Oh, mother of God. Shit's crazy, dude. I can't get the reflect to reflect the goddamn image. Why? That don't make no sense, dude. Like, it really don't. I even made a copy for it, dude. Like, if k is equal to the width and he subtracts k every time, that should be it, dude. Like, what the fuck? Oh my god. It's pissing me the fuck off. Fuck. This is terrible. 0, 0, 25, 22. I don't know, dude. I don't know. 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 I need to make sure I don't need to update this thing. Like, what if that's what it is? Update 50. Code space is already up to date. Man, I gotta make sure because I don't know why it's not. Dude, like, fuck. This sucks. I mean, expected actual 10, 20, 30. Oh, because let me see. Let me see if I can just see what it's doing. Doing absolutely nothing. absolutely nothing. Okay. cooked them too long. Oh crap. There goes up. Trying to think. This shit ain't working. Okay. Oh shit. What? Oh no. That's why that wouldn't work. Because every time it cycles through, it'd be equal to width again. That's why I wasn't doing it. It was just fucking resetting every time the fucking value. Oh my god. I didn't even think about that. Because every time I just reset the value. No, it wouldn't because it's. I don't fucking know. Fuck it. Oh man, it wants me to check every corner, every wall. Reflect, sepia, grayscale. Okay, now blur. The middle pixel. Oh, because the freaking round thing. Can I put round over here like this? I don't know. How did I round that other one? Because that one actually took it. The sepia. Right over here. What do I call this? Okay. Oh, this is gonna be a lot, dude. Let's see. Until we got something close there, at least something. Oh, the corners crap is gonna suck. How am I gonna do this? That sounds like a lot. Can I just do like an overall if as long as the value is. Oh my god, it's gonna suck. God dang it. I don't know why it's gotta be slightly off. Like, what's the point in rounding if it's still gonna be off? That's so stupid. Oh my god. That's too high. God dang, dude. That's so confusing. That's so just tedious, bro. Tedious. Are you serious? It's gonna go up and down between the fucking, oh my god, 126 to 140. Okay, how do I make this to where, man, I'm gonna have to fucking fuck, dude. Zero. So, how do I, if there's a blank spot, how do I divide it without, I gotta figure out a way to determine if one of those is a zero, and if it is, then how do I do like it? Why can't I at least get this one to match, dude? Like, what the fuck? This one's too high, this one's too low. No, wait, they're both too high. What the fuck, dude? That's so lame, dude. So lame, bro. What if I do this? Make this a double. Make a bigger number, right? A bigger number makes it work better. God, dog. has no value, then I can't copy it. If it has no value, then that needs to change. How do I make that right? Oh, now it's too low. Middle pixel, dude, you son of a biscuit, bro. Come on now. That's so finicky. I can't even get this crap, dude. Hold on. Is it because I changed it to double? Can't even get this one, bro. Come on now. Shit. What the hell? How is it? Why is this number just like being so stupid? Like, look at it's. Oh my god, dude! You gotta be kidding me, bro. Like, it's either too high on one or too low on the other. That's. That's not making any sense. That's fucking. God damn, dude. I gotta figure something else out. This is killing me. I don't know why this is. Man, this was going so easy for a second there, and now it's just pissing me off again. This one. I'm able to make a blurry image, but the numbers are not perfect. I can't even get this number perfect, dude. It's making a blurry image, but whatever. I mean, look, it's a blurry image. Why can't that be good enough? And now it broke the whole thing. Now it says it doesn't even compile. Bro, like... I have to put them in colors. Oh my god, I'm losing my mind. Bro, I'm gonna lose. Okay, come on. Listen. I need to do like a if. God dang, this is gonna be a lot, dude. How do I make it to where it's... without making some crazy long thing? God dang it, I gotta poop. Oh my god. I gotta figure this out. Oh my fuck.
filter you'll implement is called blur. In blur, your task is going to be to take an image and create a blurred version of the same image, where everything is a little bit softer. Let's zoom into this image a little bit to see what this actually looks like. Notice that if this is the original image, this is what the blurred image looks like. Notice that the details are a little bit softer, and it's a bit tougher to make out. So what does that algorithm actually look like? How do we take an image and blur it, so to speak? Well, let's look at this image, a simple 6x6 image where we have red and blue. And what would it look like if we were to blur the image? Well, the blurred image might look a little something like this, where the details are a bit softer and you can't quite make out the lines as crisply or as sharply.
All I need to do is figure out a way to account for this. Show I'm gonna make like a count. I gotta figure out some way to do this shit. Wait, if you already have I, and eyes, but that's changing that. How do I make it to where it counts? No. Wait. What is it testing for? A 3x3 and a 4x4. I'm gonna do something here for like see what I mean? And then it would be like if I can make a total, or what if I kept adding to it? How the fuck am I gonna do that? Jesus Christ. Every time it adds to it. And then you could take it. And you could take it. And all you gotta do is divide it by 9. Okay. Jesus Christ. Damn it. Blue red equals. No, no, no. God dang it. Divided by 9. No, not divided by divided by a count. Count. Okay. No, how do I how am I gonna make that count differently for each one now? No, wait, it doesn't. It's for the pixel, so it'll work for that. Count. Divided by count. Be 9 for okay. So I gotta make some sort of loop. But if I have to count outside, I don't like it's gonna fucking work. God damn it. Jesus. This is it's 4 o'clock. God damn it. I'm gonna lose it, dude. I swear to God, dude. How do I? Go through every one if it has a value. How do I make it? It makes sense to do it like this. How do you make it count? Is it if? I could do an if, but that would take forever. If. if damn, but then I gotta do it for every single one. Wait, what if I could do a function? Right? Can I do a function? Or I could implement each one into that function? Image. God, because that'd be so much to put for each single one. If what's up, dude? Trying to figure out the best. I don't know. I can blur the image, but it wants me to do the corners, and it's just. I don't want to write a crazy long code for every situation for a corner in a wall. I just think if I could make it count for every time there isn't something there, that'd be a lot easier. Oh my god. Starts at 1. Oh yeah, I forgot to change that earlier. Well, might as well put that back. Become one with the suffering. That's the truth, dude. There's like you could write this out a really long way, but I really don't want to, and I know there's got to be a way around it. So I'm really just okay. If I start from 1. Because I can make it all blurry, but it's the freaking wall and corner crap. Oh my god, it's like, it's terrible. I'm gonna get my water screwed. I don't know. No. Yeah, dude, it's gonna be so much. Like, it's crazy because I can make the blurry picture that it wants me to make, but it wants to, like, have the correct numbers right here. For, like, I already did these ones, but, like, these, it wants the correct numbers for the corners, and I'm just like, who cares about the corners? The picture's blurry, like. I'm gonna get some water. Screw it. see. I do. I'll do like if. Copy. Wonder if it'll work this way. I gotta do the then count one and add that number to this number. Man, I don't even know if it's gonna work like a hole like that. That'd be so much. That'd be so much. I'd have to do this so many times.
Go back that way. Yes.
Well,
Yeah, I need those. Oh, that was today.
what?
For the Valentine's thing. That was due today.
It was due today?
Yeah.
What do you mean?
Florida candy and a carnation. Go that way. You might not get get one. Would you be okay with one at the house if you don't get it at school?
Wait, do you know if you're able to go to the school and get it?
Not right now, but I could try. I could go up there tomorrow and see if they'll take it.
Okay.
Tomorrow's
You
your
wanna take your
Valentine's
shoes
Day,
off?
right?
Yeah, I'm pretty sure.
Are you supposed to give cards out tomorrow?
Like Valentine's cards?
Yes.
I don't know. I got it. Michael, what are you doing?
Oh, shit.
Just Valentine's stuff?
Valentine's Day is on a Sunday, so I'm trying to figure out if they're supposed to give cards. If so, I gotta go get some cards real quick.
For the school?
For the kids, for the school, for them to give cards out in their classes.
Oh.
I don't get too stressed about it. It's just a...
I just, it's a Valentine's Day for the kids. I think so. Are you still on the thing?
Yeah.
I might go to the store real quick.
Alright. Well, you know where I am. Oh crap.
Alright, go. Go on.
Okay.
Ah. Oh wait. No, that's not. Okay. This might work, man. I might have to use a variable. Oh. Let's do. Screw it, I'm gonna try this. And then we'll have to do. God, I gotta do this 9 freaking times. Okay, so that's 1, 2, 3, 4, 5, 6. God dang. Okay, screw it. Let's just go. Let's go. Write this down so I don't. Oh man, I didn't even see the messages. I'm sorry. I probably left, but if you didn't leave, I'm just doing. I just wanna. I don't know what I want to get into. I just like the coding stuff. I just want to get into coding. That's pretty much. I like the coding aspect of things. I like computers. That's all it is. so I started with -1, -1. Guess I could do -1, -1. Then I could do -1 and 0. And then 0, -1. And I guess I already got 0 and 0, so +1, +1. And +1, 0, 0, and +1. Negative, and then, oh yeah, and then -1 and +1, and then +1 and -1. Okay. Alright, negative. Oh wait, you know what? I already got this. Okay, so let's say I got all the -1s. Alright, so it's red, blue, green. And we'll start with red. Let's get this down, try to get this organized. And then we'll do okay, that's 3. Oh, this isn't so bad. That's a lot of work. And next we have these 3. Okay, and now we need to do pluses. Where's the plus? This is, I don't like this. There we go. That'll work. Okay, that's the pluses. And then I'm also going to need 0, 0. That counts as a count. So I need to add 1. Count needs a, we're adding counts. So I also need to create, I need to start those at 1. No, I'm already here. I need to finish this first before I get, wait.
Is all the Valentine's parties tomorrow?
Okay, that's the plus and 0. Now I need the 0 and plus. Plus, and then negative and plus. Okay, and then plus and negative. That's not as bad as I thought it'd be. Still don't feel like it's the right way to do it, but. And this is probably the last. Yeah, this is for the normal one. I mean, I could just do that, right?
No, you're gonna stay.
Hey, it's a mess. And I do. I don't know why you talk out of you. Your feet. Ah! Things like so I won't run away. Olivia, if you let me go, I won't run away. I'm gonna get you. I'm gonna get you. Alice. Alice. Here.
Dang, I gotta do these two. Oh, crap. You okay?
Yeah, I'm gonna go get Valentine's cards for the kids.
Mm.
No. Uh-uh. I said no. No means no. Go that way.
This looks retarded. I mean, if it works, it works, I guess. But good God. Ugh, this is like a lot of conditions. This is kind of ridiculous. God dang. There's gotta be a better way to do this. Oh, wait. Yeah, okay. Dang it. Okay. And then divided by the count. Oh, crap. Does it say integer in every single one of those? It does. Oh, my God. take out that last part since that's already. What was it? These ones? Not that one. This one. Okay. Because these are, what was it? 1, 2, yeah. 2, 3. I don't know. That's 97 and 254. Crap. I didn't even think about all that. Oh, what if it doesn't like the way I did that? 97. Where's 97? Mm. 254. God damn it. It's expected one to fucking hell. What is this? I don't even know how I pulled that up. God damn it. I have to have one there. I have to have one there. Let's see. Hold on. How many do I have? God dang it. Zero. Open and close. Open. That's 3. So I need 3 right here. I hate it when it does this. Ugh. To miss this. Okay, that one's all the way at the end. And there's just 2 right there. I don't think the spaces matter. God dang it. Turn, I don't know, dude. Oh my god, what do you want from me? God damn it. Oh, fuck. I hate it when this happens. That's 97 and 252. God damn it. Expected. Wait. Oh shit, I'm missing one. Because of that one. That's what it was. Screw it, I'm just gonna check it. Because I don't even. That was so much. I'm kind of stressed. I don't even want to know. Just gonna see what it does. God bless you. Oh no. 2140. That didn't fit at all. I don't know doing wrong? Let's see. To add to the count. Table to divide. And then it rounds it off over here. Every single spot. If it's greater. 0. Maybe I need to change that. What? Booger?
That's what she's upset about.
No, she just wants to touch it. You want wifey? Olivia.
There's a boo-boo.
Here.
There's a boo-boo.
Oh my god.
I'll wipe you too. I'll wipe you too.
You want wifey? What? You're killing me, child. Dude, come on. What? Stop. God dang it. Oh my god. Okay. Can I see if it's even blurring the pictures? Of course the freaking numbers aren't gonna be spot on. Okay, let's try this. What was it called? Blur. Images. Hard. Did it make it blurry? I think it was more blurry the last time I did it. I don't even think I made it blurry. Oh god.
No.
It's worse than it was before. Oh, mother of God. Okay, started at 1, and then... maybe let's do something different here. Like, let's do... It's a group. Jesus.
Wow. Okay, but wow.
Problems, man.
Talk of it. No, that. Well, hurry, Boogie. Try. Ew. Hey, Boogie. 47.
Whoa.
No,
Olivia, stop.
No,
Olivia.
baby, that I go zippy, I go zippy, I go zippy, I go zippy. Grandma, it'll be everything, it'll be everything. Oh my God, it'll be zippy, I go zippy.
Stop. 119, 120. Stop.
For that, let's eat that.
What?
Go.
Set but not used.
Where's he go? Where's he go? Where's he go? Where's he go?
No.
Where's he go? Where's he go? Where go? Right there. No, go. This one. Okay.
Holy crap, it's so close. What the fuck? Oh. What the hell? Oh my god, this is crazy. Why? Why is it so off though? Oh, why did I put that as an integer? Okay, the count's fine as an integer, but honestly, I should just put everything as a freaking float at this point. Oh,
I love you.
I love you too. This is kind of hard, man.
Yeah, well, you're kind of smart, so that kind of helps. You got this, babe.
numbers off. Wait, no, what? I wasn't supposed to do that. That's supposed to be over here. Does that make a difference? That was kind of weird. 486.74. Why are my numbers off? Oh my god, she's not letting me do this.
You're just tired. You haven't taken a nap.
Double check everything. That saves all the values of those. Will it make a difference if I do something like this? It's gotta be greater than 0 for it to have a value. Numbers are just kind of like out there, dude. Oh.
Cora, stop.
You okay?
Set back the time.
Set back the time?
Yeah.
What do you mean? You said you wish you could set back the time?
I have to.
You have to set back the time? I'm very confused. I don't understand. You can't go back in time.
Oh, we did before, remember?
No?
If I could turn back time.
This ain't Back to the Future. God. Dude, I'm like slightly off on this thing. What the fuck? A 3x3 image. Why? I got like it plus itself, right? I did do that? I thought I did that. Maybe I didn't do that part. Maybe that's where I'm messing up. Oh, I think that is where I'm messing up. Hold on. Equals. Yeah, I think I didn't put that, did I? Oh, crap. J. That one was really close. The 4x4 was not for some reason. My numbers are too big. This one was really close. This one, on edge, that's way off. And correctly filters middle index. I feel like there's something wrong with the math, dude. Like, why is it so off? Like, someone's like 120, 127, 80, 108. This doesn't make any sense. This one's barely off. This one's barely off. This one's apparently more off. Oh, okay. Well. If I was gonna do it away, I mean, that should have done it right there. Honestly. God dang. 1, 2, 3, 4, 5. 1, 2, 3, 4. No, because it doesn't. I don't have to have it count for every single one. I just need to count for every pixel that's missing, not for colors. So it really doesn't matter. Why did I do all this extra? I could have just put this here. Like, what's the point in this? Red, blue, green. I don't know why I did that. Red, blue, green. Cause see, here's the other thing: is if some of these are different, oh no, it's like what if the division's off? That shouldn't be off, right? That's so close. Kind of. I mean, it's closer. I don't know. I'm kind of stuck on this problem right now. I didn't expect this. This is, I don't know. I don't know if I'll be able to get to it. I'm not gonna lie. You'll see me on if I can. Man. Fuck it. That's greater than 0. I would think that would work, man, but it's 4x4 images throwing it off more, and the count should only be counting if there's a value there. God, it's just slightly off, man. within the outside parameters. Right. Outside parameters. God damn it. What am I doing? Oh, I'm hitting the caps button. Plus 2. So working on that outside parameters. And then I can implement if here. Is greater than 0. Or crap, I don't think I can put this many ors in there though. If or that way I push it outside of the barrier, but no. If it's equal, I gotta have it. If it's equal to, so this, I can run it all the way on the outside, but only if it's within these parameters, then I can initiate the count. That way it's counting it all once. Okay. You okay? And then I still need to figure out a way to take L. Then it'll hold on to. Okay, so now it's only counting those. It's only counting those. Every time it goes through, it'll add.
Ooh, my skin's so angry. So what do I say, yay or nay?
I mean, feel like doing? Yeah, if you wanna, if you got energy for it, might as well. That's not gonna work. Wait. I need to just have it in the loop. Count. Plus. It's not gonna let me do that. So I'm gonna do like. God damn it. Fucking killing me, bro. Stressing me out. Oh my god, I can't. I can't figure this shit out. This is stressing me out, man. What's in the loop? The fuck? Or do I need to define it before the loop? Oh shit, that's what it is. just need it to round off correctly. Just for edges. Changing image on the fly. Oh, I'm not changing the image on the fly. I already copied the image over. But like my rounding is off every time. Like I don't know if it's the rounding, but my numbers are like slightly off every time. I tried using floats. Tried doing the rounding crap. No matter what different way I do it, my numbers are always off slightly. Like, fuck. I don't know how I got this one. Dude. What the fuck? That shit don't make no sense, dude. Like, I don't understand how I'm not able to get the middle one. That should be, if anything, four. It's 4 off. Why is it 4 off? 4. Copied it over. Run through. Got on the outside. count started. I don't do this fucking count once anyways. I'm gonna count every time. I start my count too late. The number is too low. Running down. Okay, but this will start you here. And so you run down, loop back. And then you check your first one. Right? Only if. Only if. Okay, wait. It's running on the outside. Okay. That's your height. And K is greater than or less than height. Equals to 0. Less than height. I don't think that's gonna work. Let's see. So these are gonna be 0. You're only gonna want to count these two. It's gotta be greater than 0, but less than height. That fucking work. There's some slight thing that is slightly off, dude. No matter which way I do this, like, fuck. Okay, is your height? That's what we're checking for. And it's shit's way too fucking hard, bro. God damn, this shit's way too fucking hard. Oh my god. Doesn't make any sense. I don't get it. Like, what if I just... I don't even know what it's gonna do. I give it raw numbers. I mean, that's an integer, so it's gotta... Then I'll just round it down. Doesn't matter. It's still 4 off anyways. That's what doesn't make sense. Something about the way it goes through. I mean, fuck, dude. I'm about to just fucking, I don't know. This ain't gonna work either. I just don't know what the fuck is going on. It's killing me, bro. That ain't gonna work. That's not how that works. Oh, dude. For real? What the fuck? There's no way, dude. Let's see what fucking score this gives me. I'm just fucking... I've been spending all fucking day on this stupid motherfucker, dude. This shit's like fucking retarded. I think they typed that wrong. Fuck. Dude, what the fuck? This shit don't even work, bro. Dude. Oh my god. I don't even know what kind of score that is. If I can figure it out later, I'll go back to it later, but fuck this shit. God damn, dude. I don't know how anybody fucking. I don't know. God damn it. I'm not even fucking doing this shit right now. 22s. God, I fucking suck. I'm so over it. I'm so over it, dude. That shit's fucking. Like, I was making the fucking image blur. Like, that shit's retarded. Fuck it. Recover. Oh my god. Hints. Okay, let's see. I'm not stressed out. I just need some music. Fucking. I was making hundreds on this shit, and then now I can't. Fucking. It's frustrating. Oh my god. I don't even feel like it's me. It's just the fuck. It's literally like the shit's like not rounding. I'm like I get so close to the number that they want, and it's like barely off because the rounding crap. Like I don't even think it's me, dude. I think it's the fucking program. I don't know. Maybe I'm being a little bitch about it. So fucking irritated. How do I get so fucking close to the number, dude? Like anticipations of this problem. Oh my god. I'm screwed. I'm fucking screwed. Oh my god. Download the distribution code. Shit just feels like a setup for failure, I swear to god, bro. I couldn't make 100 on it. I got an 81. The 70 to get past it, because I'm like, dude, like I can't. It's like, and I was finding ways to make the image blurry, but I couldn't get the exact numbers that they were wanting, and I don't know what it is. I think it's the fucking program or something, because like I would use the round function, and I couldn't get the number to what they wanted it at. Like I'd be like close and right there, and like the image would look blurry, but the fucking numbers would just be slightly off. Like that was fucking pissing me off. I don't know. This is bullshit. I mean, I'm trying to at least finish one. Like I was doing one a week a day. Now I'm like not fucking getting shit done. So.
It's okay then. Did you at least do like a couple days out of today?
I barely just finished what I started on for the, like, I barely did one little tiny thing that I didn't accomplish shit. I didn't accomplish anything. It was really easy, and I was knocking it out, and then I got to the last one, and it was like, I swear to God, like, even if I had the right formula, like, it was not fucking letting me have it. It was fucking... This shit don't make no fucking sense. I tried like 3 different ways, and I couldn't get the fucking number to match up. It's a piece of shit. I'm sorry, I'm just frustrated. It doesn't make any fucking sense though. It's just like, I mean, if you saw it, you know what I mean? I don't know how to explain it. It's just...
No, I'm not even entertained by that.
Trying to stress me out. Love you too.
Is this a problem that you're working on currently?
No, I just skipped over it. Like, well, I didn't. I got an 81 on it, but now I got to do the next part.
Okay. I'm making dinner, so.
Okay. this one's a little more helpful. We'll see. Maybe I can get my stressed mind working out of the stress crap. Okay. This part's easy. If argument does not equal 2 characters, right? I thought I was supposed to make it 1 character. If your program is not executed with exactly 1 line command, 1 command line argument should remind the user the correct usage to me. It says 2 single. Oh, I guess because you have the initial main. Fuck it. I guess I forgot. Fucking 1 to 0 shit. Okay, print. Open the memory card using the file command. File. And you're gonna locate card. Open the file using the command. That's a lot to try to remember. Now check that now that you check the proper usage, you can open the memory card key provided that you open card.raw programmatically with fopen as with below. You should of course check to be sure the file was opened properly. If it wasn't, tell the user to exit the program. Leave this part up to you. How do you do that? It was like if shit. Something like if. God dang it. If it's null, return 1. Yeah. Next, your program should read the data from the card you've opened. until there is no longer any data to read. Along the way, your program should recover every one of the JPEGs from the card.raw, storing each as a separate file in your current working directory. First, consider how to read card.raw all the way through. Recall that to read data from a file, you need to temporarily store that data in a buffer, and recall further that card.raw stores data in blocks of 512 bytes. As such, you'll likely want to create a buffer of 512 bytes to store blocks of data as you read them sequentially. One way of doing so is to use the standard. I wanted to. Which stores exactly 8 bytes. 8 bits, 1 byte. 8 times since it stores an unassigned positive, negative, non-negative integer that requires 8 bits of space. Okay. Create my buffer. Probably not the best idea though to use 512 as a magic number here. Odds are you can improve this design further.
Alright, kind of a strange topic, right? Magic numbers. What does he mean when he's talking about magic numbers? Well, some of the programs that we've written in CS50 so far have had some weird numbers kind of thrown in them, perhaps for reasons we don't entirely understand right now. For example, in the Mario problem, we capped the height of the pyramid at 23. We explicitly said you can't go higher than 23. But what does 23 mean? Well, if you read the spec carefully, you might have seen that the reason we capped it at 23 is because the standard height of a terminal window is 24, and so if we have the pyramid be taller than that, it might do this weird thing where it runs off the screen and, you know. What does that mean, though, in context, right? Is the meaning of 23 immediately obvious to somebody who looks at your program and maybe has a different size terminal window? Probably not. It seems like, okay, well, why is it just less than 23? In general, it's kind of a bad habit, actually, to write constants into your code. And doing so, when you actually do write a constant into your code, it's sometimes referred to as using magic numbers, which is something we generally want to try and avoid. For example, let's take a look at this simple function here. Obviously, there's no data type in C called card or deck, so just bear with me, it's a little bit of pseudocode mixed in here. This is a function called deal cards that apparently takes a deck as its parameter and will output to me a single card. And I'm doing something here where I have a loop that runs from 0 to 52, and I deal a card. Well, we've got a magic number in here, right? Do you see what the magic number is?
52.
Or more importantly, do you see what the problem is here? particularly if this is just one function in its own file in a folder that contains a bunch of different files, each of which does another thing to a deck of cards. Maybe it shuffles them, or deals a hand of 5 cards instead of a single card. Do you see what the problem could be here? Do you see the magic number I've injected into the code? It's 52, right? Like, intuitively, we probably know, okay, like a standard deck of cards contains 52 cards. But in our program, it's just kind of floating around in there. It's like all of a sudden there's a 52. One way to resolve this problem is to do this. We're very explicitly now calling out the deck size as 52. It gives it a little more intuitive meaning when in the for loop later on we then say I is less than deck size. It just seems better than saying 52. Now this does actually fix the problem. It does give some symbolic meaning to the constant. But it does kind of actually introduce another problem that might not be immediately apparent. Even if this variable is declared globally, do you recall what it means when we declare a variable globally versus locally? Even if we declare a variable globally, what if there's another function in our suite of functions that deal with card manipulation that inadvertently changes deck size, or it increases it by 1 or decreases it by 1? That could spell trouble, right? Especially if we're dealing with a set of cards where shuffling the full deck is required. If deck size is decreased by 1, for example, to 51, we're not actually shuffling all the cards possibly, we're leaving one of them out, and that value could perhaps be predicted or exploited by a bad actor. C provides what's called a preprocessor directive, which is also called a macro, for creating symbolic constants. And in fact, you've already seen a preprocessor directive, even if you haven't heard it called that, with pound include. It's another example of a macro or preprocessor directive. The way to create symbolic constants, or giving a name to a constant so that it has more meaning, is as follows. Pound define, name, replacement. Really important aside here really quick, don't put a semicolon at the end of your pound defines. So it's pound define, name, replacement. When your program is compiled, what actually happens is the compiler is going to go through your code and replace every instance of the name, of the word name, with the whatever you put as replacement. Analogously, if pound include is sort of similar to copying and pasting, then pound define is sort of similar to find and replace, if you've ever used that feature in a word processing program, for example. So for example, if I pound define pi as 3.14159.265, it's probably, if you're mathematically inclined and you suddenly see 3.14159.265 flying around in your code, you probably know it's talking about pi. But maybe we can give it a little more symbolic meaning, and we can instead say pound define pi as that mouthful of numbers that I'm not going to keep reading over and over. And what's going to happen then at compile time is when the program is compiled, the first thing that will happen is it will go through and it will replace every time it sees capital P, capital I, it'll literally replace it with 3.14 and so on, so that you don't have to type it every time, but your program still has the functionality that you expect because you're working with manipulating, multiplying, dividing, whatever it is by pi. You are not limited to this substitution for numbers only. For example, I could pound define course as the string CS50. And in this case, when the program is compiled, pound define will go through the code, replace every time it sees course with the string CS50. You'll notice here also that I frequently pound define, all my defined symbolic constants, so to speak, are always in all caps. It's a convention, it's not required. The reason generally people will use all capitals when they're pound defining is just to make it really clear that this particular element of my code is a defined constant. If it was lowercase, it's possible that it might be confused with a variable, and that's probably not a good thing to do. So this particular solution is much better than either of the previous ones. If I first pound define deck size 52, then now my use of 52, or deck size here, is a lot more intuitive and a lot safer. You can't manipulate a constant. You can't say 52 plus plus. That's not going to convert it to 53. You can't change 52 to something. You can change a variable whose value is 52, which is the first fix we had before, and you could increase that variable to 53. But you can't say 52 plus plus and have that suddenly turn 52 into 53. 52 is always 52, and so you can't inadvertently change deck size here by manipulating it. Another good side effect of this, though, is that, are you aware that not all cards around the world, or not all countries around the world use a deck of cards of size 52? For example, it's really common in Germany to use a deck size of 32, where they strip out some of the lower value cards. And in this case, if I wanted to port my suite of functions that deal with card manipulation to Germany, I could, in the first instance we showed, have to go and replace all instances of 5.2 in my code with 3.2. But here, if I pound define deck size as 32 at the very top of my code, if I need to change it, I can just go and change that one thing, recompile my code, and all of a sudden it propagates through. In fact, we can change deck size to any value we want. Can I interest you in a game of deck size pickup? I'm Doug Lloyd, and this
Wow.
is CS50.
Yeah, I caught that 52 card pickup, I swear. Returns the number of bytes that's read, in which case it should return either return 512 or 0. Giving contains creates a buffer or a block of data. And while there's still data on freed buffer 1 to card. Oh yeah, because you're reading from file card. Okay. Is equal to 512. Is equal to a data block. that way, as soon as fread returns 0, which is effectively false, your loop will end. Finally, it's up to you to determine how to programmatically create JPEGs as you continue to read from card.raw. For this, you might need the below walkthrough. Keep in mind, your program should number the files it outputs by naming each. Keep in mind, your program should number the files it outputs by naming each as JPEGs, where hashtags is 3-digit decimal number from 0 on up. Befriend sprint.f. What the fuck is sprint? Print to a string? This function prints a formatted string to a location in memory. It expects as a, I don't know. And note that sprintf stores a formatted string at a location in memory, given the precise number.jpg format for a JPEG's file name. How many bytes should you allocate for the string? Don't forget to null the null character to check whether the JPEGs your program spit out are correct. Simply double click and take a look. Take a look. If each photo appears intact, your operation was likely successful. And of course, remember to close every file you've opened with fopen. To close every file you've opened with fopen. Odds are the JPEGs that the first draft of your code spits out won't be correct. If you open them up and don't see anything, they're probably not correct. Execute the command below to delete all JPEGs in your current working directory. If you'd rather not be prompted to confirm each deletion, execute the command below instead. Just be careful with as it forces deletion without prompting you.
In Recover, we've taken a memory card from a camera and accidentally deleted all of the images. Your task is going to be to write a program to recover those images, generating new JPEG files for each. How are you going to do that? Well, first, you're going to want to open the memory card file that we'll give to you. Then, you're going to look through that memory card file for the beginning of a JPEG file. Once you find a JPEG file, you're going to open a new JPEG file that you're going to start writing to, and you're going to keep writing data in 512-byte chunks until you find a new JPEG file, at which point you can close the old one and start writing the new one. And you're going to repeat this process, looking for new JPEG files, writing new data to those JPEG files until you reach the end of the file. How are you going to do all of that? Well, let's start by talking about how you're going to open the memory card file. To do this, you can take advantage of the fopen function, which will take as its first parameter the name of a file you want to open, and the second parameter represents what mode you want to open it in, where R stands for read mode, where you want to read information from that file. As you're reading that file, though, you're going to want to be on the lookout for JPEGs. How are you going to know that an image is a JPEG? Well, every JPEG begins with a distinct header, meaning the first byte of every JPEG file is OXFF in hexadecimal. The second byte is always OXD8. The third byte is always OXFF, and the fourth byte could vary a little bit, but it's always OXE0 or OXE1 or OXE2, anything that starts with OXE and then something, so it could be OXEF, for example. These are all valid JPEG headers. So, if you notice this pattern of 4 bytes at the beginning of any 512-byte block, you can pretty safely assume it's the beginning of a JPEG file. So let's talk in a little bit more detail about JPEGs. Each JPEG is going to start with a distinct header, where the first 3 bytes, as we've talked about, are OXFF, OXD8, and OXFF. And the last byte is OXE0 or OXE1 or OXE2, anything up to OXEF. So this is the header that you're going to be looking for. And we'll tell you that each of the JPEGs are stored back to back in the memory card. After one JPEG ends, the next one begins, and so on and so forth, up through the end of the file, inside of these 512 byte blocks. So, what does this mean for how you can look through this memory card to try to find JPEGs? Well, if you imagine your memory card as a whole bunch of these 512 byte blocks, then what you can do is start at the first block of the JPEG file and check to see if you found a JPEG header or not. If you haven't found a JPEG header, you'll keep moving on, looking one block at a time, until you find that sequence of 4 bytes that indicates to you that this block is the beginning of a JPEG file. Once you find that block, now you can open up a new JPEG file that you're going to start writing to, and you can start writing block after block after block as you find more and more blocks of this JPEG file. What you'll run into eventually, though, is another block where the first 4 bytes also look like the start of a JPEG file. And when you detect that, you should realize that this is probably the start of a new JPEG file, meaning you should close the old one, you're done writing to it, and start writing to a new JPEG file that has all of these next sequences of blocks as the data within it. So you continue writing again and again, and you'll repeat this process, looking through this file until you find the start of another JPEG file, then starting to write that new file, and repeating that process again and again and again until you reach the end of the memory card, at which point you'll have found all of the JPEG files that are inside of this memory card. How are you going to read data, though, from the memory card? Well, to do that, you can use the fread function, which takes 4 parameters. The first parameter is called data, and it is going to be a pointer to where you're going to store the data that you're reading, likely some buffer of some kind that might be an array, for example. Next is size, which is the number of bytes of each element that you're going to try to read from the file. Next up is number, which is the number of those elements that you want to try to read all at once. And then finally is inpointer, which is the file that you're going to actually read that data from. And recall that what you want to do is read from the memory card file in 512 byte chunks. Once you've read one of those 512 byte chunks, though, how are you going to know if that 512 byte chunk is actually the start of a JPEG file or not? Well, recall that the JPEG file has a distinct header. So if you've read this 512 byte block into some sort of buffer, which might be an array of bytes, then what you can do is check to see if buffer square bracket 0, in other words, the first byte of the buffer, is OXFF, the first byte of a JPEG file. And likewise, you can do the same thing, checking if the second byte in the buffer is OXD8 and the third byte in the buffer is OXFF. The fourth byte is where things get a little bit tricky. Buffer is OXD8, and the third byte in the buffer is OXFF. The fourth byte is where things get a little bit tricky. Recall that there are 16 different values that buffer square bracket 3 could take on. It could be OXE0 or OXE1, so on and so on. Of the buffer is OXFF, the first byte of a JPEG file. And likewise, you can do the same thing, checking if the second byte in the buffer is OXD8 and the third byte in the buffer is OXFF. The fourth byte is where things get a little bit tricky. Recall that there are 16 different values that buffer square bracket 3 could take on. It could be OXE0 or OXE1, so on and so forth. And so what you might imagine doing as a first pass is a Boolean condition, where you ask yourself if buffer 3 is OXE0, or buffer 3 is OXE1, or OXE2, or OXE3, or OXE4, so on and so forth.
Okay. Two, three, four.
But doing this 16 times is going to get very, very tedious.
Yeah.
So to simplify, we can use a trick known as bitwise arithmetic, where I can take the bitwise AND of buffer 3 and OXF0. What that's going to do is it's going to say, just look at the first 4 bits.
Oh, hold up.
Of this 8-bit byte, and
Hey,
set
what's
the
up,
remaining
Alan?
4 bits to 0. What that means is that OXE0, OXE1, OXE2, so on and so forth, all become OXE0 because we've cleared out those last 4 bits. Then, after we've done this bitwise AND, we can just compare the results to OXE0 to determine whether or not this byte is a byte that might appear as the 4th byte inside of a JPEG. If all of these conditions are true, it's pretty likely that the 512-byte block that you found represents the beginning of a new JPEG file. So when you found the beginning of a new JPEG file, what you'll need to do is create a new file where you're going to write this data to. How do you make a new JPEG file? Well, each file should have a very particular file name, as digit.jpg, starting with 000.jpg in the order in which you find it. So you'll likely want to keep track of how many JPEGs you found so far so that you can write the correct file names in the correct order. How do you create a string of the format digit.jpg? Well, to do this, you can take advantage of a function called sprintf, where you're printing not to the terminal, but to a string, where the first
File name. I don't think I'm supposed to put that, but whatever. I'm gonna put that for now. I'll figure this out.
parameter is the name of the string you want to write to, in this case file name. The second parameter is the format string. %03i just means print an integer with 3 digits to represent it, even if a number like 0 or 1 or 2, so that you can write the correct file names in the correct order. How do you create a string of the format digit.jpg? Well, to do this, you can take advantage of a function called sprintf, where you're printing not to the terminal, but to a string, where the first parameter is the name of the string you want to write to, in this case file name. The second parameter is the format string. %03i just means print an integer with 3 digits to represent it, even if a number like 0 or 1 or 2 doesn't really require 3 digits to print out that integer. And the final parameter is the number that you want to substitute, in this case 2, where the result would be that the file name string would now contain 002.jpg instead. Make sure that file name, though, has enough memory or has enough characters to fully represent this entire file name. After you've created the file name, you can open a new file with that file name by calling fopen again, this time providing as the first argument the name of the file you want to open. And now the second argument to fopen, instead of R for read, is going to be W for write it, so that you can begin to write to this new file all of the data that you're going to find from the memory card. How do you write data to a file? To do that, you can use the inverse of fread, which is fwrite, which is going to write data to a file. Fwrite, just like fread, also takes...
Crap, hold on. Forgot to do this.
Four parameters. The first parameter, called data, is going to be a pointer to all of the bytes that you want to write to the file. Next, you need to tell fwrite how big the elements that you're going to write are. So the second parameter, size, represents the number of bytes in each element that you're going to write to the file. Next is number, the number of elements that you're going to write to the file. And finally, outPointer is the file pointer that you actually want to write the data to, likely the JPEG that you've just opened for the purpose of writing to it. And you're going to continue doing this, writing data to JPEG after JPEG until you reach the end of the file. But how do you detect when the end of the file is? Well, to do that, let's take another look at fread, which is the function that we're using in order to read data from the memory card given to you at the beginning of the program. What does fread return? Well, it turns out that fread returns the number of items of size that were read. We currently try to read number elements of size, and so most likely, if fread is able to read all of that data, it's going to return back to you number. Say that I'm trying to read 255 elements, for example, then fread is going to return to me 255. Of course, once I reach the end of the file, it might be the case that I don't have 255 additional bytes to read, and I have fewer than that. In that case, fread is going to return to me some number that is less than 255. So you might want to think about what condition you could write to determine whether fread has gotten to the end of the file or not. Let's put all of this together now and start to think about some pseudocode that you could use to implement this recover program. The first thing you'll want to do is open the memory card. Then after that, you're going to want to repeat some process until you reach the end of the card. You'll want to read 512 bytes, likely using fread, into some sort of buffer, some space in your computer's memory where you have 512 bytes worth of storage that you can read that data into. Then take a look at the 512 bytes that you've read. If it's the start of a new JPEG, which you can detect by looking at those first 4 bytes and determining whether or not it's a JPEG header or not, then you know you've found a new JPEG. So if this is the first JPEG, you should start writing 000.jpg and start writing your very first file. Of course, if you've already found a JPEG, then you'll need to make sure to close the file you've just been writing to so that you can open up this new file that you're going to continue writing to. So that's what to do if the 512 bytes you read is the start of a new JPEG. But if it's not the start of a new JPEG, what should you do then instead? Well, if you've already found a JPEG and you've already been writing to it, then you should keep writing to it. This is the next 512 byte block of this current JPEG that you've been writing to. And you might repeat this process multiple times because every JPEG might take up multiple blocks of memory inside of the memory card that we've given to you. So you'll repeat this process, reading 512 bytes, and then check it. If it's the start of a new JPEG, you might need to do something. If it's not the start of a new JPEG, you might need to do something else. After you've reached the end of the memory card, then you should close any remaining files, and if all goes well, you should be done. And you should see you might need to do something else. JPEG might take up multiple blocks of memory, part of a new JPEG. What should you do then instead? Well, if you've already found a JPEG and you've found a new JPEG. So if this is the first JPEG, you should start writing 000.jpg and start writing your very first file. Of course, if you've already found a JPEG, then you'll need to make sure to close the file you've just been writing to so that you can open up this new file that you're going to continue writing to. So that's what to do if the 512 bytes you read is the start of a new JPEG. But if it's not the start of a new JPEG, what should you do then instead? Well, if you've already found a JPEG and you've already been writing to it, then you should keep writing to it. This is the next 512 byte block of this current JPEG that you've been writing to. And you might repeat this process multiple times because every JPEG might take up multiple blocks of memory inside of the memory card that we've given to you. So you'll repeat this process, reading 512 bytes and then check it. If it's the start of a new JPEG, you might need to do something. If it's not the start of a new JPEG, you might need to do something else. After you've reached the end of the memory card, then you should close any remaining files, and if all goes well, you should be done. And you should see that you've now generated a number of JPEG files, each of which contains image data that you can then open up and view visually. My name is Brian, and this was Recover. Of this current JPEG, start writing your very first file. Of course, if you've already found a JPEG, then you'll need to make sure to close the file you've just been writing to so that you can open up this new file that you're going to continue writing to.
Fuck, god damn it.
Dinner's ready. Take a break or I can bring it to you.
I should have got a lot harder on this part. It said online this was the hardest part, so if I could just get past the next two sections, it's this one and the next one.
You gonna take a break or you want me to bring it to you?
Huh?
You gonna take a break or do you want me to bring it to you?
If you don't mind bringing it. I'm just trying to make some progress. I'm not really making any.
You're good.
I wish they went over this more, like, let me see. I'll post some videos where he says, like, because I don't know what I'm allowed to put here, because, like, here, it just goes based off the file. Alright. I can't put card. That's supposed to be the file name. Where's the file name supposed to be? Fucking. Can't put that. I don't know, dude.
Chicken and rice, baked chicken on CS, baby. It's hot. It's hot, baby.
Oh, what is it?
Baked chicken and rice.
Oh. Thank you.
You're welcome.
I love you.
I love you too.
Sorry, I haven't done this in days, and
No, you're good. Are you still okay with me going out or no?
that's fine. What time?
9, so it'd be leave around 8:30, 8:20.
Alright,
If not, I have no problem canceling.
alright, that's fine as long as you don't come back super late.
I don't plan to.
Yeah.
I'm already exhausted.
Mm.
So that's what to do.
At the moment, here too, I should check if file equals null. Okay, fine. Return 1, and then maybe at the very bottom here, I return 0 to make clear. Nope, nope. If I get this far, all is well. So in short, anytime you are dealing now with pointers, you should be checking the return. Suppose I want to copy this file from source to destination byte by byte. Similar in spirit. Instance, let's see, my name, 617-495-1000, and watch the top right of your screen as the program F writes to it and F closes the contents. All good. All right, let's run it again because maybe like the iOS app or the Android app, I'm adding new friends to my phone book here. So I'm going to do ./phonebook, and I'm going to go ahead and, top right just got turned blank. Well, let's try this. Kelly, 617-495-1000, enter. Okay, she's back. Let me run it again. ./phonebook, gone. Well, what's going on here? It's not persisting, at least as long as I would like. It seems to be the case that like writing to a file means literally then I'm going to pass in the values name and number respectively. And now I'm going to go ahead and do fclose to close that file so that it's effectively synced. .h for this, and let's include string.h for this. Then inside of main, no command line arguments, let's go ahead and open a file called phonebook.csv. CSV stands for comma separated values. Many of you have probably used them in the real world. They're like very lightweight spreadsheets where things are effectively stored in rows and columns, where the columns are represented by just commas between values. And we'll see this in just a moment. How do you open a new file called phonebook.csv? Well, I'm going to do file star file equals fopen phonebook.csv, and then I'm going to do quote unquote W for write. So what's going on here? fopen is opening a file, whether or not it exists yet, called phonebook.csv, and it's opening it in such a way that I will be allowed to write to it. Hence the quote unquote W. Per the documentation, it means I can write to this file and not just read it. The return value is going to be stored in a variable called file, all lowercase by convention, but that file is technically a struct called file in all caps. It's a little weird. It's among the few things that is fully capitalized in C. It doesn't mean it's a constant or anything like that. It's just how someone implemented it years ago. This is giving me a pointer to essentially the contents of that file. That's a bit of a white lie. It's technically giving you a pointer to a chunk of memory that represents that file, but for all intents and purposes, it's a pointer to the file for now. Now let's go ahead and ask the user for a name and number to add to this phone book. Let's do char star name equals get string, quote unquote name, to prompt the human for that. Char star number, let's prompt them for that. And with this, and I could be using the string data type, but I'm trying to at least remove what training wheels we don't technically need anymore. And now that we've got a name and number in variables, let's print them to the file. That is, let's save them to the file. Instead of printf, we're going to use fprintf. We're going to specify what file we want to print to, in case we have multiple ones open. What do I want to print? A string, followed by a string, followed by a new line, ergo, comma, separated values, one after the other per line. Then I'm going to pass in the values name and number respectively. And now I'm going to go ahead and do fclose to close that file so that it's effectively saved. All right, so let me go ahead and demonstrate first that phonebook.csv does not really exist. It's empty initially. Let me go ahead and scooch it over to the right here so we can see both at the same time. I'm now going to do make phonebook, enter. So far so good. /phonebook. And let me go ahead and type in, for instance, let's see, my name, 617-495-1000, and watch the top right of your screen as the program fwrites to it and fcloses the contents. All good. All right, let's run it again because maybe like the iOS app or the Android app, I'm adding new friends to my phone book here. So I'm going to do /phonebook, and I'm going to go ahead and, top right just got turned blank. Well, let's try this. Kelly, 617-495-1000, enter. Okay, she's back. Let me run it again. /phonebook, gone. Well, what's going on here? It's not persisting, at least as long as I would like. It seems to be the case that like writing to a file means literally rewrite the file. So if you use W, you're going to write to the file, but literally starting at the first byte. If you want to be smart about it and append to the file, well, per the documentation for fopen, you instead use quote unquote A for append instead of quote unquote W for write. This is a convention in other languages too. All right, let's start this over. Let me go ahead and recompile this program, make phonebook. Now let me do /phonebook. I'll type in my name again first, 617-495-1000, enter. So far so good. /phonebook. So far so good. Kelly, 617-495-1000, enter. And now we're on our way. In fact, I can close this file, I can close this file, I can then open up phonebook.csv, and indeed, it has persisted. And in fact, if I download it, it's going to be stored in a variable called file, all lowercase by convention, but that file is technically a struct called file in all caps. It's a little weird. It's among the few things that is fully capitalized in C. It doesn't mean it's a constant or anything like that. It's just how someone implemented it years ago. This is giving me a pointer to essentially the contents of that file. That's a bit of a white lie. It's technically giving you a pointer to a chunk of memory that represents that file, but for all intents and purposes, it's a pointer to the file for now. Now let's go ahead and ask the user for a name and number to add to this phone book. Let's do char star name equals get string, quote unquote name, to prompt the human for that. Char star number, let's prompt them for that. And do it with this. And I could be using the string data type, but I'm trying to at least remove what training wheels we don't technically need anymore. And now that we've got a name and number in variables, let's print them to the file. That is, let's save them to the file. Instead of printf, we're going to use fprintf. We're going to specify what file we want to print to, in case we have multiple ones open. What do I want to print? A string, followed by a string, followed by a new line, ergo, comma, separated values, one after the other per line. Then I'm going to pass in the values name and number, respectively. And now I'm going to go ahead and do fclose to close that file so that it's effectively saved. All right, so let me go ahead and demonstrate first that phonebook.csv does not really exist. It's empty initially. Let me go ahead and scooch it over to the right here so we can see both at the same time. I'm now going to do make phonebook, enter. So far, so good. /phonebook. And let me go ahead and type in, for instance, let's see, my name, 617-495-1000, and watch the top right of your screen as the program fwrites to it and fcloses the contents. All good. All right, let's run it again because maybe like the iOS app or the Android app, I'm adding new friends to my phone book here. So I'm going to do /phonebook, and I'm going to go ahead and, top right just got turned blank. Well, let's try this. Kelly, 617-495-1000, enter. Okay, she's back. Let me run it again. /phonebook, gone. Well, what's going on here? It's not persisting, at least as long as I would like. It seems to be the case that like writing to a file means literally rewrite the file. So if you use W, you're going to write to the file, but literally starting at the first byte. If you want to be smart about it and append to the file, well, per the documentation for fopen, you instead use quote-unquote A for append instead of quote-unquote W for write. This is a convention in other languages too. All right, let's start this over. Let me go ahead and recompile this program, make phonebook. Now let me do /phonebook. I'll type in my name again first, 617-495-1000, enter. So far, so good. /phonebook. So far, so good. Kelly, 617-495-1000, enter. And now we're on our way. In fact, I can close this file, I can close this file, I can then open up phonebook.csv, and indeed, it has persisted. And in fact, if I downloaded this file onto my Mac or my PC, I could then right-click it or double-click on it and probably open it in Microsoft Excel or Apple Numbers. I could import it into Google Sheets or any number of other spreadsheet tools, because now I am persisting and writing files of my own. Questions on any of the techniques we just tried out here? If we really want to be nitpicky, like technically I should fix one bug or missed opportunity. If I open up phonebook.c, I'm going to propose that, as with any use of pointers and addresses more generally, here too something could be wrong, like maybe I'm just out of space and so fopen can't physically open the file for me. So here too I should check if file equals null, okay fine, return 1, and then maybe at the very bottom here I return 0 to make clear, nope, if I get this far, all is well. So in short, anytime you are dealing now with pointers, you should be checking the return values to see if all in fact went well. Yeah. Yes, everything we are using is part of standard.io.h, which is wonderfully useful now because it has not just printf, but fprintf, and so forth as well. Good questions, yeah. Yes, so we have to, how are pointers used in this code? The short answer is you have to use pointers because this is how C designed files to work. So we couldn't really introduce you all to file IO in week 1 or 2 or 3 because we had to introduce like this stupid little character to you, and you'd be like, what does this mean? It's not multiplication. Because the way file IO works is that when you open a file, you are essentially handed the address of that file in memory. That's an oversimplification. You're technically handed the address of a data structure in memory that references the file actually on disk. But for all intents and purposes, as I said, this gives you a pointer to the contents of the file. And if you want to write to the file, you need to then use fprintf. In this case, tell it what file to write to so you can go there and then store something like this string and these values plugged in. So in short, in C, without pointers, you just can't do file IO unless it's abstracted away for you by some library. Good question. Other questions? File IO. All right, example, let me do one other example here that's a little reminiscent of things we see all the time on our phones and laptops and desktops, like these progress bars for like video players, and you're all probably generally familiar with the term like buffering, if only because YouTube and other apps, when they are slow or you have a slow internet connection, they might say buffering ... Well, what does that mean? Well, a buffer is just a chunk of memory. More specifically, it's often an array that is only a finite size that stores bytes of stuff. Well, in the context of a video player, for instance, this red line here, which represents you're that much through the video, it's an array that stores like the next few bytes of a video. And ideally, if you have a fast enough connection, when you hit play, those bytes keep getting downloaded and added to the buffer, and hopefully you don't finish watching the bytes that have been downloaded before more bytes have been downloaded. So a buffer is just a chunk of memory, or more specifically, an array in a language like C. Well, just to demonstrate how else you can do things with file I/O, let me propose that we write a simple little program that is our own implementation of the CP program, the copy program that we've used a few times already, that allows you in your terminal window to copy one file to another, likening it to this idea of a progress bar where byte by byte you want to do something, namely in this case, copy it, not watch it instead. So let me go in VS Code and code up a program called cp.c, and in this program I'm going to go ahead and include standard io.h at the top. I'm going to then give myself a main function that this time does take, finally, a command line argument via int argc and our old friend string argv, which today we can now reveal to be also just a char star. In fact, this is how we can now technically write the declaration for main. String no longer exists without the CS50 library per se, so that's really what's been going on this whole time. Now let me go ahead and do this. I want to be able to write a program that takes two command line arguments, actually, the name of the file to copy and the name of the new file to create from it. So let's go ahead and create a file using the same syntax as before, called src for short, source, as is a convention, and let's open a file using the file name argv bracket 1, so the first word the human types, and let's go ahead and open it in read mode, because I want to read the source and write to the destination. My next file, file star dst, destination for short, will be fopen of argv2, comma, quote unquote, write. Now why 1 and 2 and not 0 and 1? In 0 is the name of the program, which is not interesting. 1 and 2 will contain the next two words that the human types. Now, let me propose that I want to copy this file from source to destination byte by byte, similar in spirit to a buffer like this, where you're just grabbing from the internet one byte of the video at a time so as to watch it. In this case, I want to copy it. So how can I do this? Well, we don't have a data type per se for representing a byte, 8 bits. However, a common convention is to actually use our new friend typedef and simply declare byte to be something significant or something.
Parameter is the format string. %03i just means print an integer with 3 digits to represent it, even if a number like 0 or 1 or 2 doesn't really require 3 digits to print out that integer. And the final parameter is the number that you want to substitute. Write the correct file names. When you found the beginning of a new JPEG file, what you'll need to do is create a new file where you're going to write this data to. How do you make a new JPEG file? Well, each file should have a very particular file name, as digit.jpg, starting with 000.jpg in the order in which you find it. So you'll likely want to keep track of how many JPEGs you found so far, so that you can write the correct file names in the correct order. How do you create a string of the format digit.jpg? Well, to do this, you can take advantage of a function called sprintf, where you're printing not to the terminal, but to a string, where the first parameter is the name of the string you want to write to, in this case, file name. The second parameter is the format string. %03i just means print an integer with 3 digits to represent it, even if a number like 0 or 1 or 2 doesn't really require 3 digits to print out that integer. And the final parameter is the number that you want to substitute, in this case 2, where the result would be that the file name string would now contain 002.jpg instead. Make sure that file name, though, has enough memory or has enough characters to fully represent this entire file name. After you've created the file name, you can open a new file with that file name by calling fopen again, this time providing as the first argument the name of the file you want to open, and now the second argument to fopen, instead of R for read, is going to be W for writing, so that you can begin.
Struggling over here, bro. It won't take this fucking file. I don't know how I'm supposed to write this. I don't understand. I'm so fucking confused. I did that. Fuck me, dude. Oh my god, this shit's so. God damn it. This don't make no fucking sense, dude. shit's fucking. I don't know what I'm doing wrong here. Like, header. Okay, see, this one's the same, right? Wait, do I have to maybe, god damn it, create like a file? Like something like this. I don't think it's gonna work like that. There's gotta be more to it. Man, this shit ain't easy. I don't even know, dude. I'm trying. I'm trying to fucking figure it out. No, that doesn't work either. God damn it.
Someone at the front door. So let's create file stuff, dude. Let's see.
doing wrong, dude? Like, fuck me. File image equals file open. File name. What the fuck?
This time you're switching it up. Got some quesadilla. Good job, baby. Daddy's doing his classes right now. I don't even want to go.
Nobody said he had to. Nobody said he had to.
I know, we already told him everyone. Tattoo appointments be so extra.
Man, they were right about this shit being hard at this part. Like, god dang, dude. I'm like struggling to find the information I even need, dude. Like, this is so fucking hard. It's not like they don't give you the answers or like nothing. Like, you barely even touch this stuff. That's what's so frustrating about it. Like, fuck, dude. This part's killing me. Fuck me. Why's this shit gotta be so fucking... It's like all the other shit, it's been so much more information, and then this part has just been fucking bullshit. I don't know, dude.
Do you think I did a good job? Yes. Do you think she's gonna love it? Yes. I think she's gonna adore it. What does that mean? It just means like really, 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 really love it. Dada. Dada.
What?
I got a present for Miss S for Valentine's Day.
You can have half of it.
Okay.
There's only 8 half room.
Look.
Deal.
Deal.
The other half I'll better see on the table.
What should I do with it?
I'm gonna throw it away. 'Cause that's what you do with the other bit of your food, right?
This shit's hard. Oh my gosh, it's so fucking complicated.
Is it cold outside?
Holy shit. $144. Oh, I'm an idiot.
So you're gonna be down for the day.
Mm.
Well, I was semi-dressed up. Oh,
Don't sound very motivated.
I'm not. I'm tired and my guts hurt.
Oh, well. I mean, you don't have to.
It's too late. I already made promises.
Well, you don't make a lot of sense.
Well, this is all your idea. Now you gotta reap the repercussions.
I do or you do?
See all of the above. What?
What should I do with the other half of my food?
The other half of your food?
Yeah.
I don't know. Throw it away.
Okay. Cool.
I gotta take a shower. Sprucing up.
Mm.
I'm gonna go work my ass off. Work.
Hey, working? You getting paid or what?
That'd be nice. You sexy motherfucker. I love you.
Me?
Yes, you.
What? Because I'm sexy when I'm stressed out?
No. I'm sorry. I'm sorry you're stressed, babe.
Mm.
I'll stay if you want me to.
I don't know. I'm just trying to get this shit figured out.
You're like, no, your ass gonna go.
I don't know. I don't know what you want. I can't tell what you want.
No, can't tell what I want.
Huh?
Can't tell what you want.
No.
Or do I know what you want?
I'm trying to get this done.
No, that's you're like, it's fucking done.
I'm just fucking trying to do this.
You got it, babe.
That's where my mind's at. Shit's fucked.
Alright, I'll stop taking around. Take a shower. And go to work.
You know, when you gonna go to work and give me my tattoo? You keep telling me.
Bro, I got so much on my play. I'm gonna drop your tattoo, babe. I haven't even forgot about you. You're getting it. You're gonna get it. You gonna get it.
I swear.
Mama,
Yes.
can you show me a picture of Mika?
Yeah.
Because I really want to make her on go to left hand.
How do you spell her name? Miku?
Yeah, it's gonna take a while for me to get down, dude. I already have all that. I don't understand this fucking. This shit is hard as hell. Like, this shit's fucking. Dude, they don't give me enough information to figure this shit out. I swear to God. That shit got me so stressed out. Wait, I got read. Where do I got write? That's the right. I'm trying to figure this shit out, dude.
Alright, let me shower. Make this make sense. Let's try this shit. Cause I'm struggling, dude. It's all three of them.
Dude, could y'all leave her alone?
Olivia?
What?
What are you talking about?
What do you need? She's
I
like literally taking a shower.
Oh, I forgot.
You know she's taking a shower, you can hear it.
But Mama told me her password, but I forgot it.
For what?
Because I was using her computer. I mean, not computer, but her phone, so I could make Miku on Gacha Life too. Yes. It's happened.
Oh, I was able to recover one picture. Oh, so I did do it right. I just didn't have it in a loop. What? I already have the defining value. Expression unused. is. So my input is the card.raw. It can only be a single character line. If I don't, then it lets me know. If it fails to open it, I have null. Return one. Okay, so create a buffer for a block of being, and this knows my data block that I know the file will be within equals 1, so that gives it a chance to go through. I think I only got one file. I'm doing something wrong. This shit's hard. Close the image. Counter does not equal 0. Close the image. That's what it was. Okay. This would add the counter. Man, I need to play with these a whole lot more. This is fucking character name up to 8. Man, I'm gonna need to practice these a whole lot more, because this is fucking killing me. So once it passes these conditions, then I can pass it to here. Then once it passes here, then as long as counter does not equal 0,